It was a decent question to ask, but when you're finding the y coordinates of the inflection points, you want to plug it into the original function, because plugging it into the second derivative will always give you 0.
Okay. Okay, I didn't think about that, but yeah, that makes sense.
You're forgiven. You just learned it like 2 days ago. So.
Literally yesterday. Or yeah, was it yesterday? I don't know. I don't even know anymore.
Yeah, I know. They all come together.
Yeah.
I learned it sometime.
Yeah.
Sometime before today at 11 o'clock.
Did they have that board meeting yet, or?
The times vary, but I think the board meeting is tonight at 7.
Oh.
If you miss the board meeting, they archive it. So if you're interested, I'll send you a link.
Okay.
If you want to.
Like, I don't know if I can make it to this one, but maybe the next one.
No, but you can watch it. You can watch it afterward. They archive them.
Oh, okay.
You know what I mean?
Yeah.
So you don't have to watch it live. I almost never do.
Oh, okay.
But you can watch them online.
Oh, they're gonna want fraction. I typed this in my calculator, and there's a way you can make the decimal into a fraction.
Math.
Uh-huh.
Convert to frac. Enter.
Huh. It didn't work.
Sometimes it doesn't.
It does.
If the decimal is too long, it may not convert it. So you may have to do it by hand.
Okay.
But usually math convert to frac is what.
Yeah. Because this is -4 over √3 to the 4th power.
Okay, so -4 over √3 to the. Okay, so take each
term and just
term individually. Yeah, so -4 to the 4th is going to be, what is that? 256, I think.
Oh yeah, 256.
And the fourth, what did you say? The bottom was the 4th root of 4?
No, it's the square root of 3.
So the square root of 3 to the 4th power should be 3 to the 1/2 to the 4th is 3 squared. That should be 9. So you should get like 256 over 9, something like that.
Okay. Yeah, that makes sense. Okay. And then this is going to become positive. 2 times 8 over 3 plus 3.
Yeah, sometimes if it's irrational terms, it doesn't convert to a fraction as readily.
Like, hopefully I did the whole problem right, because this is a really ugly fraction.
What are you trying to put? What did you get the inflection point of? What are you trying to plug in?
Well, I got it as 4 over root 3 plus and
Okay,
minus.
so that's your inflection. Okay, so, and what, I can't, let me see if I have did you try watching it?
Yeah, I'm pretty sure it's right, but it's just
You're still having
because
a hard time plugging it in after that?
no, it was pretty easy, but it was just like a really ugly number that I got for my, I mean, I guess it's possible, but I got negative 254 for my local minimum value, which I thought was really,
Well, let's graph it and find out. If you see, it's a fourth power, so it's driven by the fourth power behavior. But if you think it might be not, it's the fourth minus 32x squared plus 2. Okay, so hold on. I'm opening the calculator right now. Let me share the screen here. Stop sharing yours temporarily. Let's be share. And then we have y equals, y equals x to the 4 minus, is it 32x squared?
it's
32x squared plus 2?
yeah, let me
That's what I remember, right?
exit and look at the x to the 4th minus 32x squared plus 2.
Plus 2. So let's see. I need to zoom out.
It does look like it goes pretty far down.
Yeah, see?
Oh, yeah, it has to be like negative 254. Yeah. Okay.
So, I mean, I could change the setting, but it looks like this is -4 and negative 254.
Mm-hmm.
So,
The reason I ask is because I end up with 3 fractions, and then one of my fractions has a denominator of 9. The other one has a square root of 3, and the other one's just a 1.
let's do it and see. Let's do if you're having trouble on the manipulation, let's do it, because you're probably going to have to do it or something similar on the test. So let's make sure that you feel comfortable.
Because if I have to find like a common denominator 9.
Hold on, let me write so it's x to the 4th minus 32x squared plus 2. And what was it? You're trying to plug in the negative right now? Negative square root of 4 over 3?
Well, no, this is for the second derivative part. So, oh, you're right. Yeah, it's the original function.
What was what was the x that you're trying to plug in?
It was -4 over square root of 3.
-4 over the square root of 3. Okay. So you get
So I had
-4 over the square root of 3 to the 4th power minus 32, open parenthesis, -4 over square root of 3 squared plus 2, right? Now, in this case, my idea would be if you didn't feel comfortable if you're doing it by hand, right? You were using the calculator, would be to take the power to each term. So I get -4 in parenthesis to the 4th over square root of 3 in parenthesis to the 4th minus 32. Now we can probably square it pretty easily. Negative 4 squared is 16 positive, and square root of 3 squared is 3,
Oh, okay.
right?
Mm-hmm. Yeah, that would
Plus 2.
be better.
So then negative 4 to the fourth is whatever 4 to the fourth is.
It's 256. Mm-hmm.
So 256, and if you're not comfortable with the square root of 3 to the fourth, you can enter that in your calculator, but that's 256 over 9.
Yeah.
Now you get minus, now the 32 has a 1 under it, but right now you're multiplying, so all I'm going to do is multiply 32 by 16 gives you what?
32 times 16 is 512.
512 over 3, right?
Yeah.
Plus 2 over 1. Now, if you were going to get a common denominator, it would be 9, right? Sorry, no, I lied. Yes, it would be 9.
Yeah.
9 and 3 and 1. So the common denominator is 9, which means I leave 256 alone.
Mm-hmm.
256 over 9. Now, the 512 I have to multiply by 3 because I need a 3 at the bottom,
That's
right?
1536.
1536 over 9. And then the 2 I have to multiply by 9, so I get 18 over 9. So now I just combine those three. 256 minus
It
1536.
becomes plus, right? Because of the negative and the negative.
Well, remember we lost one of the negatives because negative 4 over the square root of 3 squared was positive. So we have 256 over 9 minus 5
Okay.
minus 1536 over 9 plus 18 over 9.
Okay, got it.
So 256 minus 1536 plus 18.
And I put that over 9.
Well, just right now, just give me the top.
Oh, okay. It's negative 1262.
Okay. Now, if you divide that by 9, I don't know if it's 3, 9. No, it wouldn't go in exactly, but it might
no.
reduce by 3.
No, it didn't.
Okay.
I just leave it like that, I think.
Yeah, the concavity, you're getting a different number, but if that was the real, but it's close, so it might be even lower than that, actually. We don't know yet.
Okay.
We have to see how.
So now we have to do the same thing with the positive, but wouldn't it come out to the same value technically?
The positive value.
If you're squaring it and you're also getting the
it should. The y should be the same.
Yeah.
Because the one is the fourth power,
And the second
one is the second power, and it didn't change any signs. It's an even function, so.
Yeah, it has the same.
So it should.
Symmetry.
Mm-hmm. Symmetry with respect to the y-axis.
Yay. Oh, I just missed this one because of my comma, and I didn't put.
Oh.
Okay. Hopefully that's right.
You have some sense, so if not, then I'll go back. And what parts did it mark your inflection on?
The interval which my function's decreasing, which I thought it was from negative infinity to. Oh, it's negative 4. Oops. That's why. There we go. Okay. Oh, this one looks fun.
But you see what we did?
Yeah. Yeah, it makes a lot of sense to me. I don't know why, but when it comes to the graphs, I feel like
You
it's,
understand it.
yeah, it makes sense. It's just, I guess, when you're doing the algebra, it's like, what am I doing? You know, sometimes I
You
get
feel like it's more abstracted.
yeah.
Well, it is a different way of thinking.
Mhm.
Geometry is a different way of thinking than algebra.
Yeah.
And some people naturally think more in that way. So it's a more natural way. Not that some people can and some can't. It's just a more natural thing for some people to do.
Yeah.
Yeah, you've been having a hard time with your manipulations in this class.
I know.
You can share your screen if you need to again.
Oh, I forgot about. You can't see. That is no. This one.
Oh, you're afraid of the trade. It's not a. This is a easier derivative than the last one.
Mm-hmm.
What's the derivative of 3 sine x?
It's 3 cosine x.
And what's the derivative of 3 cosine?
It's negative 3.
Minus 3 sine. Now you're going to turn it back around. So what's the derivative of 3 cosine x? It goes back to
negative 3 sine x.
right? And what's the derivative of negative 3 sine x?
Negative 3 cosine x.
Be careful. Almost. The derivative of negative 3 sine x. What's the derivative of sine x?
It's
Cosine.
cosine.
It's negative, remember, but you're doing negative sign. So it's going to switch. It's going to switch back. So sine and cosine switch, but the signs in the middle are different. Right? So your first derivative, hold on. Your first derivative is going to be, hold on here. F of x is 3 sine x plus 3 cosine x, right? So f prime of x, the derivative of sine is cosine. So you get 3 cosine x, right? The derivative of cosine is negative sine. So you get negative 3 sine x. That's the first derivative, okay?
Okay.
So the first derivative is 3 cosine x minus 3 sine x. Now, if I differentiate that one, the derivative of cosine is negative sine. So I get negative 3 sine x, okay? And then the derivative of sine is positive cosine. So I get minus 3 cosine x.
Yeah, that's what I got.
So the second derivative has 2 negatives in it.
Yeah.
Negative 3 sine x minus 3 cosine.
Yeah, that's what I got.
Okay, good.
Yeah, because I was like, what am I doing?
You weren't.
Okay.
Doing anything wrong.
Okay.
You weren't. You thought you were, but you weren't.
Okay.
Okay? Now find the interval on which f is increasing. F is increasing. So we have a couple of ways we can check this, but usually when we talk about increasing and decreasing, that's the first derivative, right?
Yeah.
So we want to look, if we're looking at increasing and decreasing, we want to look at the first derivative and we want to know what?
When when the in between the factors equals, or when x,
Well, before we get to that, when you want to find out if a function is increasing, or yeah, when you want to find out if a function is increasing, you take the first derivative, right? And you look for places where it's greater than 0. That's
Okay.
going to be where it's increasing. So you want to know your first derivative is 3 cosine x minus 3 sine x. And we want to know where that's greater than 0. Okay?
Okay.
Now, what some people do is they set it equal to 0 and then they test. I don't know if that's what he does.
Yeah.
Okay, so you can set this equal to 0 first, right? And find the critical numbers and then test it.
Yeah, that's what he
So
does.
3 cosine x minus 3 sine x is equal to 0, right?
Mhm.
So we're going to set one function. Here it's going to be a little hard for us to factor. So I'm just going to say that 3 cosine x is equal to 3 sine x. Divide both sides by 3 and I get cosine x is equal to sine x, right?
Okay.
Now, where is sine x equal to cosine x? Where are they equal to each other? At what angle?
Oh, at pi over 4?
Right. At pi over 4, that's in quadrant 1, right?
Mm-hmm.
Or the other angle is in quadrant 3 as 45 degrees. So that's going to be 5 pi over 4, right? So
Yeah.
one angle is x is pi fourths. That's one answer. And the other answer is, now we have to do it on 0 to 2 pi. So pi over 4. The other answer is the quadrant 3 answer, which is 5 pi over 4. Now what we have to do is test. So one point is pi fourths. The other point is 5 pi over 4. And what we want to do now is check this inequality, 3 cosine x minus 3 sine x, to see where it's larger than 0, right?
Mm-hmm.
So if I'm looking at the interval from 0 to pi over 4, let's say, or from negative infinity to pi over 4, if I use 0 there, I get 3 cosine of 0. So use 0 as a test point. 3 cosine of 0 minus 3 sine of 0, right? So what is the cosine of 0?
1,
And so 3 times 1 is 3.
3.
What is the sine of 0?
Oh, sine of 0
Is
is
0.
0.
And so you get 3 there. So between negative infinity and pi over 4, our function is positive.
Mhm.
So it's increasing on that interval, right?
Okay.
Now what's happening to it between pi fourths and 5 pi fourths? Well, let's check a value. What do you want to check between pi over 4 and 5 pi over 4? What do you think we should use?
Pi over 2.
Okay, or we could use pi, either one, whatever you feel.
Oh, yeah. Pi would probably be better.
Pi, okay.
Yeah.
So if we use pi over 2 would work also. Don't think it won't. I just thought pi would be.
Yeah.
What is the cosine of pi?
It's negative 1.
Uh-huh. And what is the sine?
Huh? So it's negative 3.
So
And then 3 sine of 0 is
3 sine of pi
3 sine of
would be
pi
0,
was
right?
0. So it's
So you get
negative.
negative 3. So yeah, it's negative, right?
And it's
Less than
decreasing.
0. So it would be decreasing from negative pi over 4 to 5 pi over 4, right? What happens after 5 pi over 4? What should we put in?
Can you put in 2 pi?
2 pi, that works for me. 2 pi is 8 over 4. So what is the cosine of 2 pi?
It's 1.
Okay, so we get 3 there, right? Minus 0,
0.
and so it's positive. So now, that's our little analysis, right?
Uh-huh.
So where is my graph on the interval from 0 to 2 pi? Where is my graph increasing?
So it's from negative infinity to...
Now be careful here, because it only tells you where's x from. 0 to 2 pi, right?
Okay.
So be careful there. We can't use a bigger
So,
interval than what they're giving us.
yeah, so you have to go 0,
0
parentheses, 0
to
to
what?
pi over 4
Union what?
to 5 pi over 4
To
to
what?
2 pi.
There you go. See? You're getting it. Ding!
Finally.
No, you have been. It's just taken you a while to get
Used
some
to.
understanding. Yeah, exactly.
Where is that? Oh, we passed it. Okay. 5 and my pi. 4. And it's decreasing from pi over 4 to 5 pi over 4.
And if you want, you could graph the original function and verify that. But
So this is where we do the plugins for those into the original function.
find the local max and minimum values of f. Okay, so now remember this is local max and local min, right? Not absolute max. Now, if you have a local max or a local min, right? It will either occur at the critical numbers, right? Or it will occur at the endpoints. So you have to plug in the
Critical number.
plug in the critical numbers. And what are the critical numbers here?
Pi over 4 and 5 pi over 4.
Right. You have to plug in the critical numbers. And what else do you have to check? You have to check the endpoints, 0 and 2 pi,
Okay.
right?
Mm-hmm.
So do all that good stuff. And
Okay, so f of 0 will be 3 s 0.
I just realized I'm eating my hair. That's not good.
1.
How you doing? Okay.
Yeah, I'm good.
I'm just continuing to slurp, so let me know.
Okay. You eat soup almost every day, huh?
No,
Oh.
last night we had, what did we have last night? Oh, chicken wings, like, but the kind that you buy frozen.
Uh-huh.
Chicken wings and what did we have with our chicken? Oh, broccoli. And then the night before that we had spaghetti with I don't remember what they served after that. But sometimes my housemates buy their own food. That's what was going on last night. So everybody had different food last night.
Oh.
I ate what the facility was eating, and then my other housemates ordered food.
Mm-hmm.
But we eat a lot of soup because we have a lot of veggies.
That's good.
And they can cook the soup, and then they can, they can serve it for several meals if they want.
Yeah. I like making soup. It's pretty easy. It's not hard.
It depends on how you make it too and how many ingredients there are.
Yeah, because the prepping is what takes time. But once you are done with that, you just stick it in the crock pot and call it a day.
Yeah, or I think they use like a huge, like almost not a double boiler, but one of those high walled frying pans that holds about a gallon.
Oh, yeah, the stock pots. Mm-hmm.
Yeah, it's.
Yeah, I have one of those too. I use sometimes.
Well, you have quite a few people there, right? That you have to feed up.
Yeah,
So.
yeah, exactly. I try to only cook for once, for a
Yeah,
minute, so
exactly.
I don't have to cook all the time.
Are you one of those people that like you pick a day to cook and you cook for like a whole week and then you freeze everything?
Oh no, I wish I had that much time, but I don't.
Mm.
I was actually planning on doing that with my second pregnancy, but it just never worked out that way. I mean, I think I froze like a couple and then that was about that, but I think that would be a good idea though.
But your children are weaned, so you don't have to at least you don't have to worry about
Yeah.
feeding them every 3 hours, but now you have to worry about them being up all the time.
Yeah. Okay, so I have 2 so far. Now I'm doing 5 pi over 4.
Well, we know they're gonna be equal to each other, right?
Mm-hmm.
So the sine of 5 pi over 4 should
It's the
be
same thing as rad
yeah.
2 over 2. Yeah. Yeah.
It's negative, but I mean they're gonna, you know what I mean? So
Yeah. So there's 2 pi is good.
I'll make sure my phone is charged in the morning so I can leave it on for you if you need to text me.
Okay.
If you so you don't have the little panic you had last time.
Thank
Sorry,
you.
I didn't mean to cause you anxiety, but I didn't realize that you were having until 4 o'clock.
Oh, you're fine.
No, I know it worked out, but I hate to just,
I know. I was like, oh, thank God she answered.
No, I try to keep tabs on that.
Yeah, I know. We're planning to do that test together, me and someone.
Oh, you found your group?
Yeah, I texted one other person, but I mean, I texted her through the
Pronto? Or
pronto, yeah, and I reached out. So she said she was interested, but I gave her my phone number, and I don't know. We'll see if she wants to do it still or what.
whatever.
But yeah, because I know it's kind of like a last minute thing. But I was thinking about creating like a Zoom account
Oh. Uh-huh.
so that I could.
Well, you could enter like a small team or something.
Huh?
You don't have a Zoom account?
No, I've never created one, so.
But the school has one for you, don't they? I thought they had converted them. That's what they said they did, but I don't know if they were supposed to convert all the student ones.
Oh, I don't know. I don't think so.
Really? Hmm.
Okay, so the values that are the largest is 3.
Okay.
And
So
then
and where does okay.
I have 2 values at 3 rad 2.
Uh-huh. But is that the minimum? Is that the smallest it gets?
No, the smallest is 1.
So we just want the local max and the local min.
Okay.
You don't want the absolute, you want the local minimum. The minimum for the ones around it. So if you look at so here, let's do something here. Let's look at, so that you understand, because 3 sine x plus 3 cosine. So I'm gonna stop sharing this for a second.
Okay.
And I'm gonna go to, do I have decimal open? Yeah, I still do. So this is, let me turn this graph off. Can you see the screen?
Yes.
Okay, so we are looking at y equals, oops, y equals 3 sine x, can't spell today, 3 sine x plus, and I'll fix the interval in a minute, 3 cosine x, right? So let me fix this over here. We'll go from 0 to 2 pi, right?
Mm-hmm.
And I remember there was a pi on my keyboard. I was looking around for it yesterday like crazy and I couldn't find it. And then I'm like, it was right in front of my face. And then sometimes that happens. And then the y-axis, let me close the keyboard, is equal to, we'll change this to -5. Actually, yeah, okay, -5 to 5. Okay, right. So something like this. This is what your graph looks like. Let me extend it slightly so that we can let's try 3 pi. Just so that you see what, without it hitting the so oh, and I forgot to change it to radian, but that's okay. So if you'll notice here, that remember 2 pi is going to be right here, okay?
Okay.
Where this, so it goes basically from 0 here
Mm-hmm.
to 2 pi right here where this peak is at,
Okay.
right?
Yeah.
So basically your local minimum is also going to be your absolute minimum, right? And it's going to occur right here. You see that?
Yeah.
And if I change this, I didn't change the scale, but if I change it to the radian, right? Then I scale this by x-axis we scale by pi over 2, let's say, there. Then you'll be able to see it more. This will probably look better to you,
Oh, okay. Yeah.
right? So now you have, there's your point right here, right? And I can label this is your, but your inflections are the second derivative, but that's where your minimum's occurring.
Okay.
You see it?
Mhm.
And then we have 2 local maxima, right? Because they're at the same place, right here. You see it?
But if it's just going to 2 pi, would that second one count though?
The one at 2 pi is lower than the one at whatever this is, pi over
4 maybe.
4. Yeah. Because if I turn this off and I just take this to 2 pi, the only reason I didn't want to do that before was because I wanted you to, it didn't want to run up against the, you can see that it doesn't have another max
Yeah.
till after. It comes up, but it doesn't, it's not as high as this one,
Okay.
right? But this qualifies as a local because there's still values lower than it and higher than it around it.
But the one on the right doesn't.
Correct.
Okay.
Exactly.
Okay, that makes sense.
Very good.
Yeah.
And I hear my annoying little voice in your head the whole time, right?
So I got my local min as 1. Would that be incorrect then? Based on this graph, it looks like it's not 1.
Your minimum is what?
Yeah, because I plugged in f of 0 and I got my local minimum as 1.
Well, you thought 0 was the minimum, but maybe the minimum doesn't occur at 0, remember?
Mm-hmm.
So
So I must have plugged something in wrong.
f of 0 is 3 times the sine of 0, that's 0, but the cosine of 0 is 1, so that would be 3.
Oh, I didn't multiply it. Oh my gosh. You're right. Okay.
So I think you're plugging, you're using the right numbers, but you're not.
Yeah, I just didn't plug that 3 in. Ah, so many mistakes. Okay.
Use the calculator to help you. You know what I mean?
Yeah.
You know how to do that or no?
Yeah.
Okay.
Yeah, I know.
I mean, plug it into your calculator and then have it calculate it for you.
Yeah.
So you're not breaking your head doing all the. Because the arithmetic is killing you, Sam.
Yeah.
I mean, really, the algebraic manipulation is coming along, but the arithmetic is really kicking you right now.
Mm-hmm.
But you understand the material.
Yeah, it's just like for example, for pi over 4,
Mm-hmm.
I got 3 rad 2.
Okay.
But when I plugged in 3 rad 2, the value is like 4.2 something. So that would be my maximum.
At pi over 4?
Yeah.
Yeah, because that's right here.
And that's 4 point. Yeah. But I didn't.
If I graph, just to show you, if I graph y equals pi over 4, right? Then I'm gonna have that line, pi over 4, sorry. I didn't want to graph y, I wanted to graph x, not y. I wanted to show you where pi over 4 is this green line, right?
Mm-hmm.
So your maximum is right here. Pi
Yeah.
over 4 and 4.243, which is the decimal approximation for what you're giving me. Yeah.
Sorry. Can you hold on one second?
Mm-hmm. Are you waiting? Oh, you popped out.
Hi. Sorry.
No, I didn't realize that you left. I thought you were just gonna. So I got the ding, and I thought that you left, but you didn't.
Oh.
You just, you know what I mean? I thought either you left or somebody walked in, and I wasn't sure which one. Does that make sense to you?
Yeah. Yeah, it makes sense.
So you're on the right track.
So when I did that 5 pi over 4, you know how the values became negative?
Mm-hmm.
So it basically makes the whole problem a negative value of 3
Right.
rad. Okay.
And you should end up with a negative number.
Mm-hmm. Okay, so that's my min, and this is my max. Okay.
Because at 5 pi over 4, you're over here. You see it? Let me get the keyboard out of the way. You see where you are?
Huh?
You're down here. If you look at the screen, you're down here now. So x is 5 pi over 4, right?
Uh-huh.
And you're at this point down at the bottom.
Yeah.
So and that's a negative
Yes.
same that you got before because it's symmetric. Okay. Good job.
So I do the second derivative, which is the negative 3 sine of x
Minus 3 cosine.
So in this case, would you still set them equal to each other like you did before?
Well, you're doing the, okay, so when you're looking for concavity, You're looking for the second derivative to be 0. So, yeah, it's the same. The same story. And it's essentially the same equation, isn't it?
Yeah, except you get a negative on the...
Yeah, it's just the flipped.
So would that make it x equals... So when it's the negative sign of x equals the cosine of x?
So basically, sine and cosine have different signs.
So it'd just be...
So
Like-
now it's pi over 4, but they're in quadrants 2 and 4.
2 and 4.
Because
Yeah.
they have to have opposite SIGN signs, right?
Yeah.
So that's going to be, that is going to be 3 pi over 4, right?
Mm-hmm.
And 7 pi over 4.
Okay. In that case, you plot... I usually...
I'm going to step away for like 2 minutes
Okay.
to go return my bowls to the kitchen and wash my hands, and I'll be right back, okay? Hold the fort while I'm gone.
All right.
Try not to learn more than I know. Bye. And I'll come back soon. I'm back.
Okay.
Did you miss me?
Yeah. I was actually just about to get some coffee that I just made. So I'll be back in a minute. I'm going to use the bathroom too.
No problem.
Okay.
Great minds think alike. That's one of those. Let's see if I have hydrocolloid, but I'm thinking that I can use. The elements should help with each other. It should help with each other because it has that one right now. But I might need the other two because this one is not very. There we go. That should do. Put some skin on it and just like rub it in. God. And from his raised. Let me try one of it. Where's the first part? The big old dot. Then I want to find it.
Hello.
There we are.
Okay, so it
Oh,
says,
you moved on. No. Good for you. Got another one, huh?
yeah. I know these ones are a little bit shorter because it looks like there's a lot of multiple choice type
Right.
ones.
Something or
And this
other.
one looks kind of long.
Yeah, but it's just asking you to do the whole analysis.
Yeah.
That's all. Well, I'm gonna leave the meeting open until 8, and Carla will be here at 6 or so.
Okay.
So if, when she comes, you can just silence your mic or whatever, or you know how to use the raise hand feature under participants? You find it?
I think I
It's
saw it.
under if you
Maybe
go
let me
to
stop.
participants and you go to I think you have to go to the little, I have to find it myself. No, it's not that. I thought it was the gear, but I think there is
Oh,
a.
it is. It is. It's on the bottom. It says raise hand on the bottom right corner under
Yeah, but on the
participants.
host thing, it says, I have it on a different, because I have the screen
Here,
out.
I'll try it.
I think
And then,
mine is, I have to pop out the participant window. And then, yeah, I see your hand there.
okay.
I see it. Yeah, and then you
Okay.
can, yeah, so I'll leave the participant panel open.
Okay.
And then if you have a question, you can just pop in. And I don't think it's going to take us the whole 2.5 hours to, I don't think she might need maybe an hour, maybe. Because I can always give her more time tomorrow, but she does have a homework assignment to finish. So, so
Okay.
I wanted to help her finish it. It's for econ.
Mm.
You know anything about economics?
Yeah, I actually did take.
Oh, well, maybe you can help us. She's studying, right now she's doing macroeconomics, and they just started talking about what? Oh, binding, when you change the, I forget what it's called, but what is that called? I had it in my head right now. And I
Raise.
had it in my notes where like a rent binding for the market, like rent control.
Oh.
If you lower the rent below the equilibrium point,
Uh-huh.
then it's binding. But if you don't, then it's not binding. And how the equilibrium point moves. So
Oh.
Nominal versus real GDPs.
Yeah, I remember that stuff.
And I don't know. Hey, I'm like, I don't know anything about it. She's like, read it and explain it to me. I'm like, okay. So maybe
I don't know if they still have it online or how it works, but I remember they had like underneath the Success Center, like where, you know, it's like the bottom part of the building, they had a room for tutors that taught macroeconomics.
that do economics. Yeah, no, I know. She's not taking the class here. She's taking it at Irvine Valley.
Oh.
But she's not a student here anymore. But I was looking to see if, but you we might be like, I'll give you a tutoring credit if you no. If we get stuck, we'll let you know, because she's been doing the class for a little while.
Yeah.
But she just asked me to take a look at some of it, and I don't know anything about it at all. Like, so I was doing my cram session this afternoon. But with these chapters, at least you understand them.
Yeah.
So look at the test. That's going to be my first piece of advice to you, is look at the test and find the problems that you understand how to do.
Yeah.
And do those.
Yeah.
For your confidence. You know what I mean?
Yeah, that's what Professor Hugan told me too.
Oh, because that's what happened to you on the last test. You got into one that you couldn't do, and then it just kind of
it just
messed with your head.
Yeah. I know. And I think the fact that we're home and we have to do it like right next to your computer, you just want to look up the answers because it's right there. But I have to know, I'm like, okay, stop myself. I know this. I don't need to look it up. You know.
Well, maybe like mark it.
Thank you.
Mark it, and then if you feel like you really don't know, you can look it up after you've looked at every problem once.
Yeah.
You know? That way you have a chance to look at every problem. And then you can, now do I have another page? Just ignore me, I'm talking to myself right now.
Okay.
I'm just making a quick capture for when Carla comes.
Okay, I'm gonna mute myself and I'm gonna eat.
Yeah, no worries.
Okay.
Yeah, just do your thing, I'm here.
Okay, thank you.
See me? Hey, Carla. So, I'm working with Sam right now. She's taking a break, And I told her that she could go ahead and stay in the meeting, and then if she has a question, because she's just working on homework right now. So I told her if she has a question to just use the little raise your hand thing, and I would come back and answer it. But she also said that she remembers some of the stuff from economics. So actually, I don't know how much background she has, but she said that she might be able to help you. Maybe. So I don't know, but we'll see what we're doing, and then we'll see if I just mentioned it, so I don't know, but she wasn't sure. So I figured that you can ask her when you're here, and then maybe. But you can go ahead. I just sent you to your email. I sent you like the 2 pages of notes I took. And then once you join the meeting, what I'll do is I'll open up a Google Doc and I'll make it so that you can write on it. Because I started outlining it. So you know how you said you wanted to see what I was doing? I didn't get very far in the outline, but it's something that I can show you in a few minutes. So you can see how I would suggest that you go through it and then you put in stuff. You can, yeah, you can. That's why I was calling, but I was just letting you know that she's here. So I heard the bell go off. I'm just adjusting my chair. So I'm gonna do that. And did you get the email? Do I need to send it to your other here? What is your other? I don't think I have your other one. The whole thing? Hold on. Let me first let you in to the meeting. Because you're.
I'm looking at a video right now, and you know, like I really wanna. Okay, let me see.
You want me to mute you temporarily, or? Hi.
Huh?
I said, do you want me to mute you?
Sure, if you want to. Yeah, you
Or
want.
are you, because you said you were watching a video, so you said you were watching a video.
Yeah, I was watching a video because I was trying to understand this one, you know, like the second page that I told you about. And
Well, share the screen. You know how to share the screen?
no, I don't.
Okay, so go to you're on Zoom, right?
Yeah.
So go to the bottom up and you'll see a green suitcase.
Yes.
Click the green suitcase.
Uh-huh.
And it'll say share your desktop or share the application. So what you have to do is make sure that your worksheet is open or whatever you're working on.
Oh, okay. Okay,
And then you can share the worksheet.
Okay, cool. Okay. Let
So
me do
just open up the application.
Yes.
Put the application either in a window or on your desktop.
Shauna, you're gonna be getting a lot of clients from all over the world with Zoom.
I don't know about that, but I'm still learning a lot about how to actually broadcast the material, but I know how to use the platform. You know what I mean? Because I figured that was the easiest. I mean, I was in control panic mode for a month trying to.
Yeah. Oh, you were?
Well, yeah, because I told you the fiasco that happened, right?
Mm-hmm.
When they said they were going to train us, and then they trained us by giving us information the day before that they realized was completely unworkable, and then they changed it.
Yeah.
There it is.
You got it?
Yeah, I see it. Can you see it?
Yeah, I can see it. Yeah.
You see?
But where are you?
You and I are looking at the same thing.
But what are you looking at?
I'm seeing the second page. It says consider the following graph.
Yes.
What I need you to do, because it's really small,
Uh-huh.
hit the control and then the plus sign on your keyboard. Control and then plus. Together. Hold down the control and hit the plus.
Okay, let me see.
It should enlarge it. No, on your keyboard, not on the keyboard.
On the keyboard.
On your computer keyboard, where you type.
Yeah,
Where
okay.
you type. Find the Control key. Should be somewhere on the left-hand side near the bottom.
Uh-huh.
And then find in the document. You should be enlarging it.
Okay, how about if I go like this?
Well, that works too.
Yeah, okay.
Okay, so it says mark. Okay, that's good. Now, hold on. Let me not.
and I was, uh-huh.
So it says mark the equilibrium. So the first curve, this curve that goes up to the top, that's your supply curve, right?
Yes, that's correct.
Increasing one. And the curve that's decreasing from price down to the x-axis, that's the demand curve, right?
Correct, yes.
Now the equilibrium price is the point where they cross.
At 50, right? At 50.
50 is the quantity, and the equilibrium price is 50. It looks like it's 50-50, if I'm
Yes.
reading it right.
Yes.
Okay, so that would be the equilibrium price and quantity, okay?
Yes.
Now, it says shade the area of consumer surplus and producer surplus. Okay, I didn't read this part.
Yeah, I think I was reading, that's what I was kind of getting into a video. So, you know, like, I don't know if you can see this one. Can you see this one?
Okay, so what you have to do is stop sharing that one. So go down to share.
Uh-huh.
Where you were before.
So go back to new, go back.
Stop the share that you have going right now
Uh-huh.
and switch to the screen that the video is on.
Oh, okay.
So stop the share that, you know what I mean?
Yeah.
Stop the share that you're doing right now. And go, now.
Yeah, I was, yeah.
Play the video. And turn up your speaker.
Okay. This is like a different one, you know, but at least it's gonna tell me, you know.
Supply curve.
Now, what I would do is go ahead and go back to the beginning of it, the beginning of the video,
Yeah.
or the beginning of where you were. Turn the captions on if you have it, so I can read the caption. You know what I mean?
So you want me to go to the ones, to the one that
No, if you go to the little gear icon down here, the little gear icon in the video.
which
In the video that you're watching, on the right side, you're on the left side. Go to the right side. Go to the right side. Next to that. Click on it.
my right. This
Click
is my
on.
right.
Okay, you're fine, but click on the settings. The gear. Keep going. Okay.
Uh-huh.
You don't have captions on this video. That's the problem.
Mm-hmm.
So it's just hard for me to hear it, but keep playing it.
Okay.
So the answer here is 20. So where does the supply curve come over and see that it's $20? Now the second question is find the total producer surplus when the price is $20. So we're saying, okay, price is $20. The producer surplus is going to be above the supply curve and below the price.
There you go. So surplus is below. You think surplus is below?
But the thing is, he said something about there's two different kinds.
Okay, let me see.
Area of surplus.
But this consumer, see, he's only got one curve, so this is not helping me.
No? Okay. How about if I move forward a little?
We need, hold on, let me see if I can, hold on. Producer, hold on.
I'm getting it from YouTube, Shauna.
I know, but I'm gonna try if
You can find another better? Another
I
better video?
want to see how they're related. Consumer surplus is the gap between the price that consumers are willing to pay and the market equilibrium price.
I think you have like a formula, Shauna, like 1/2, and then parenthesis, base and height.
Well, because that's a triangle, but hang on, let me look it up. Wait a second.
Okay.
How do you find? Okay, let's see what this says. Don't know what this is.
Consumer surplus. Surplus, I think, is above. Surplus, I think surplus is above.
Yeah, it's above, but I don't know when I'm looking at I need to find the relationship in the curves. So let me see if they, let me see what this one says.
Consumer.
Okay, so it says the production surplus can be thought of as the area between the horizontal line at the equilibrium price and the supply curve. So I need to write this down. So let me see. So let me see if this helps me.
Okay.
So I'm gonna take this. Where are my notes from? English, price controls, econ, here it is.
It's a dead weight. Prices down. Why demand? Let's look for the floor setting. Ceiling.
I'm gonna share this. Hold on. But I need to unlock this.
See, like this, like this video.
Hold on. I've got too much stuff going on in my, because I'm trying to find it for you. And you were saying? Okay, go ahead.
No,
I'm looking.
I say that I have this video, but I don't know if this is the same thing or not, because this is like a floor, floor.
So it doesn't really matter whether you supply 14 buyers actually purchase only 5 units. So this is what's called
Surplus. Excess supply.
or surplus. And that's the extra product that's either sitting on shelves or needs to be purchased by the government. So we've got that situation. Now what happens with...
And then he talks about the triangle.
Well, consumer surplus and equilibrium, remember, it's this entire triangle here. Consumer surplus is the bonus amount, the amount that consumers value the good or the service, but they actually don't have to pay it. They only have to pay the $5 market price. So it's almost like a savings. It's a bonus. They go down to the shops. They're willing to pay, say, $9 for the good, but only have to pay $5. So normally consumer surplus is this entire triangle here. What's happened here is...
So it's from the equilibrium point to the
So-
equilibrium point to the top of the demand curve. So that would mean put your other graph, because I don't have that graph, remember?
Yeah, I know. Yeah, let me see. Let me see if I can.
You just switch the screen share, that's all.
Can you see it?
No, you have to switch the screen share. You're still sharing. There we go. So you draw, okay, so draw a line through the, draw a line through the equilibrium here,
Uh-huh.
through the middle, like from there, and then you would have, because the supply, the demand, so it's gonna be this triangle from the top to the
Right,
equilibrium.
it's gonna be like, I don't know if you can see that, right, Shauna?
Looks like it.
Right?
That, yeah, but I don't know which surplus that is.
So I did the equilibrium, and then I did the triangle, like from the.
I don't know, yeah, but I don't know which surplus that is. That's what I'm saying.
Oh.
I don't know if that's consumer. So play the video again. It is this, but I don't know which surplus it is. I don't know if it's consumer or producer. That's why I was looking for the definition, and then you found the other video, so I don't know which surplus it is.
I know, because yeah, I know, Shauna. No, come on.
You work out consumer surplus by looking at the point at which the market's going to operate. Draw a horizontal line to the vertical axis there, and consumer surplus is everything sort of between the demand curve and that horizontal line that you drew. So that's consumer surplus.
I see, he's saying it's consumer, but I don't know why. But I don't know if that has to do with the floor or what. So I have to look to see which one is. Let me see that's why I was looking it up.
Okay. Let me see if I find something to here.
Well, I almost had it, and then I had, because my issue with having Zoom meetings is sometimes I have too little bandwidth, and I have to control that for like all the. Okay, so let's see. I think this might be something. Let me check it and see what. Oh yeah, this is from Lumen, but it's a different module. So yeah, okay. So look at this here. Let me share the screen. So I'm gonna stop sharing yours. So that's my screen here. So if you look, you see it?
Yeah.
So my equilibrium point in this case is at E, okay?
Uh-huh.
It's at 28 and 880, right?
Yes.
And my demand curve is this bottom curve here. So the consumer surplus is the triangular region from the base of the equilibrium point to the top of the demand curve. So it's this curve right here. It's this triangle F. So you have it. So that triangle that you shaded, that's consumer surplus.
Okay, consumer surplus. Okay. Okay.
Because it says that the triangular area F in the graph shows the area of consumer surplus, which shows that the equilibrium price E was less than what many of the consumers were willing to pay. So many of the consumers up here, see, they were paying higher prices, right?
Yeah.
And the equilibrium point was down here. So consumers are paying more than what they would normally be willing, that's consumer surplus,
Okay.
okay?
Mhm.
Now, producer surplus is on the same side, but it's the triangle below it.
I see. Okay.
So it goes from E to the bottom of the supply curve. From E to the bottom of the supply curve. The somewhat triangular area labeled by G shows the area of producer surplus.
Mhm. Okay. I think we got it, Shauna.
That's producer surplus, which shows that the equilibrium price received in the market was more than what many of the producers were willing to accept for their products.
Okay. Okay.
Okay, and I screenshot that so you could see. Now, so that's all right. Now what else?
So the number 2, let me see.
Now you have to share.
Yeah. I know I have to share. Okay, can you see this one?
So open it and then go to the bottom and hit the green suitcase again. There you go.
Yeah.
That's it. Now it says, okay, so we did that. Now it says for 20 units, what was the buyer's willingness to pay? So for 20 units, so you go to 20, right?
Yeah.
And so, and remember that we're looking for how much the buyer was willing to pay.
So they're paying 20, right? Right?
So the 20 is the quantity, right?
Okay. 20 is the quantity. Okay.
Right here on the x-axis, right?
Yeah.
Now, if we're looking for, just like we did before, if you look at, because I did a screenshot of this, okay, so I think I did, yeah. So if I have to look back to see which, so we're looking for what the consumers were willing to pay. You're looking at the demand curve. So you need to look at the demand curve, and then you need to look at 20 and see. So you have 20 on X, and you're looking at the demand curve, which is this steeper one, right?
Mhm.
So at 20, you follow 20 up to the bottom of the, and they're paying, I can't see what that number is.
Let me
But
see.
it's the higher one. No, on the y-axis. I can't read it, it's too small. This is 20, 40, I can't tell what the increments are.
Quantity is 10, 20, 30.
So okay, so I'm telling you, go to the x-axis, go up to the top curve, the demand curve, and tell me what that number is. Is that 80? They're willing to pay 80.
Oh, okay, Shauna.
Because
Yeah,
the buyer's willingness to pay is going to be on the demand curve, not the supply curve.
Oh, okay. I was doing the supply. Okay, so 20. If I follow 20 up, it's gonna be 80, Shauna.
Yeah, because it's on the demand curve, remember?
Yeah. That makes sense. Okay. That makes sense.
Now that's how much they're willing to pay, right?
Okay.
Now the consumer surplus, okay? Now this is where your triangle comes in, because the consumer surplus is going to be based on what we just looked at. So the equilibrium price, now this I'm not sure of, because the equilibrium price, I don't know if we need the whole area or just the difference between the two. You know what I mean? But the equilibrium price is 50. They're willing to pay 80. You see?
Yeah.
So I'm not sure if it's 30 or if it's the whole area of the triangle.
I'm not sure either, Shauna.
But you get the seller's willingness to accept at 20 is going to be 20. So for C under, I'm sorry, for D under the first blank, that's going to be 20.
Okay, now, okay, so, the D 20 units, what is the seller's willingness
That's
to
20.
accept?
That's 20. That's 20 because the supply curve, see where 20,
Yes.
see that's, in terms of computing it, I don't know if you just need the difference between the two or the whole area. That's my only thing. You see what I mean?
Shauna, you're getting it in there, Shauna. You're getting it. You're getting it.
But are you getting it? You're the one that has a task.
Okay, so we just have to find out what is the consumer surplus.
Yeah, but I don't know.
You don't think it's based on the 20 units, Shauna? Like you don't think we have to look at that?
Well, it is. I don't know if we're looking at 50 minus 20, or if we're looking at the whole area of the triangle, which is 50 is the base.
How about if we Google how to do consumer?
Well, I did that. That's where I got the other. So hold on.
How to what?
Oh no, it would be something like. Hold on. Let me stop. Let me stop sharing all this. Let me open up my browser.
Okay, I'll be really quick. I'm just gonna turn off my oven and then come back. Okay? Give me 3 minutes. Okay.
In this lesson, we're going to talk about the concepts of consumer surplus and producer surplus in relation to the supply and demand diagram. First, let's define consumer surplus. Generally speaking, consumer surplus refers to the extra
I'm gonna do is I'm gonna go back to the Zoom meeting. I'm gonna go to the chat function. Chat, and go here. Chat. Carla.
I'm back, Shauna.
I'm here, dear.
Thank you, Shauna. You know, I
Take
gotta
a look at the chat.
take
Take
a
a
look.
look at the chat function. You see it?
Oh yeah,
You see the link?
yes. Click.
That link, I'm going to share the video right now. I'm going to run it through my Zoom, but that link does a problem that's exactly like this.
Oh, okay. Oh, Shauna, you're so good at it.
Okay?
Mm-hmm.
So I'm going to share the video right now,
Mm-hmm.
but I have to make sure I have the right tab open first. Okay, so now this might be more than what we want, but Carla,
Yes.
you can see the video, right?
Yeah.
Okay. Let me get rid of this notice. Let me turn it on. Okay. Now.
In this lesson, we're going to talk about the concepts of consumer surplus and producer surplus in relation to the supply and demand diagram. First, let's define consumer surplus. Generally speaking, consumer surplus refers to the extra benefit enjoyed by the consumers in a market who pay less for a product than they were willing and able to pay for it. Let's look at the market for movie tickets that we see here on the left. First, notice that the supply and demand curves for movie tickets were derived using the equations we see above. QD equals 80 minus 5P, and QS equals negative 24 plus 8P.
You don't have to worry about the equations.
There's clearly
You don't have to worry about the equations for now. You just have the lines. He's just telling you they came from equations, and that's what the equations of these lines are.
Okay.
Okay? Because they come from mathematical. They didn't just, fall out of the sky somewhere.
clearly an equilibrium price of $8 per ticket and an equilibrium quantity of 40 tickets. Let's examine how consumers who were willing and able to pay more than $8 feel about paying a price of $8 in this market. To do so, it's useful to think of the demand curve as more than just demand for a good. It also represents the marginal benefit of all consumers in this particular market. Benefit, of course, means happiness. And as we learned earlier in the course, the more of a particular good is consumed, the less additional benefit the consumers of that good get out of it. Therefore, the more and more people who go to movies, the less additional benefit society enjoys from going to additional movies. Therefore, the demand curve represents consumers, all who are willing and able to pay different prices for movie tickets. The yellow line I'm drawing here represents all the consumers who will ultimately buy movie tickets at a price of $8.
So all of these people in yellow, this is the demand curve, okay?
Yes.
And these people, remember, this is 8 right here. This is the price they pay, right? And these people pay more because this goes from 8 all the way to 16. So these people are willing to pay more for their ticket.
Since we have thousands of consumers in this market, this blue demand line represents thousands of individual consumers, each with a different willingness and ability to pay, or a different demand. Now I'm placing several say at $6, certainly there are a lot of people who would be willing and able to pay $6 for a movie ticket. But since
Does that make sense?
Yeah.
Okay. So
the price is greater than $6, consumers whose willingness to pay less than $8 are no longer going to be in the market for movie tickets.
so these people, they can pay less, but now they wouldn't get as much benefit from it. So that's not where their happiness is, right?
Mhm.
Because they're lower, because there'd be a lot of people going and they wouldn't enjoy it as much.
Mhm.
Let's look at those consumers who are going to be in the market.
We're talking yellow
Each of
people.
them, represented by an individual dot along the demand curve, will have a certain amount of consumer surplus or additional benefit that they enjoy since they only have to pay $8 for their movie ticket. Ultimately, we can see that the entire area below the demand curve and above the equilibrium price of $8 represents the total benefit of all of the consumers of movie tickets in this market. Some who are willing to pay as much as $16 for movie tickets, others who are willing to pay $15, $14, $13, and so on, all the way down to the equilibrium price of $8.
So that yellow triangle is our consumer surplus,
Yeah.
okay?
Mhm.
From the equilibrium line to the top of the demand curve.
Okay.
That's your consumer surplus. That's the shaded region,
Okay.
okay?
Mhm.
This yellow triangle now represents the total consumer surplus in the market for movie tickets, or the total welfare of all the consumers who buy movie tickets who are willing and able to pay more than $8. We should see that at one point on the demand curve, there is a single consumer who is willing to pay exactly $8. So how much consumer surplus does that person have, or do those few people have? At a price of $8, clearly somebody who pays $8 will have no consumer surplus. That doesn't mean they're not benefiting. It just means they don't have any extra benefit or additional benefit or consumer surplus. But the thousands of consumers who buy tickets at $8 who are willing to pay more than $8 clearly have extra benefit. Hence we say consumer surplus is the extra benefit enjoyed by consumers in the market who pay less for a product than they were willing and able to pay for it. Graphically, consumer surplus will always be the area of the triangle below the demand.
Okay, so here it is. Consumer surplus, this is how we're going to find it, is the area of the triangle
Curve and above
below the demand curve and above the equilibrium price. So consumer surplus, when we calculate it, is going to be the area of this triangle.
Oh.
Okay.
Okay.
And the way we get the area of a triangle, I don't know if you remember, but that's a little bit of mathematics. You take the length of this line, the length of it, so you're looking at the x-axis, the length of this line from 0 to the equilibrium point, which in your case would be 50, okay?
Yes.
And then you multiply that by the height. Now the height is going to be from the equilibrium price, which was, I think, 50, right?
Yes. Yes. Yes.
And where is your maximum for the, is it 90? I don't remember.
80.
It's 80,
Yeah.
the highest point that the demand gets.
Oh, the highest is 100.
So we're gonna take those two, and so let's go back. Let me stop sharing this temporarily. Well, let's watch him first. Hold on.
price, which on our graph is the triangle I've shaded in yellow. We should be able to easily calculate the area of this triangle and thus give a monetary value to the amount of consumer surplus in the market. Let's do that now. The area of any triangle is a formula of 1/2 times base times height. Since we see that our price intercept in this particular demand graph is 16, we can quickly calculate the consumer surplus.
So the price intercept he's talking about is the maximum where the demand hits the vertical axis.
Okay.
Okay?
Uh-huh.
So go to your price axis, find where the demand curve hits the price axis. That's what he's calling the maximum.
Surplus as 1/2 8 times
Now, you know where he got 8 from?
Yeah, the equilibrium.
No, 8 comes from 16 minus 8.
Oh, okay.
The top minus 8 down here.
Okay.
So in your case, let me stop sharing the screen.
Uh-huh.
Hold on. Let me stop sharing this. So now go ahead and share your screen. I need the graph again.
Can you see it?
Not yet. You have to share your screen, Carla. You have it up, but I need you to share your screen. So hit the green suitcase
Okay.
and share the screen that the graph is on.
Did you get it or no?
No, you haven't started sharing yet.
Okay, share.
There you go. Now you have. Now I can see it. So so this point is 50-50, right?
Yeah.
So this top triangle, the triangle that we're talking about, the base goes from 0 to 50, yes?
Yes.
So the bottom is 50. Now, the way you figure out the height is you go from, see this line where the equilibrium point is?
Yes.
That's 50, right?
Yes.
And up here is 100, yes?
Yes.
So that height is 50 units,
Yes.
because that's 100 minus 50, right?
Yeah, correct.
So the base is 50, the base is 50, the height is 50,
Okay.
right?
Mm-hmm.
And then you take those two numbers, you multiply it together, and then you take half of that number.
1250.
1250 is the 1250 is the
Consumer surplus?
consumer surplus, yeah.
Okay, so
But now that's the whole consumer surplus, okay? Now at 20 units, that's going to be a different triangle.
oh, I see.
But that's what he's saying, okay?
Okay.
Consumer surplus is that whole. So when we were shading the area of consumer surplus
Uh-huh.
at equilibrium, that's 1250, okay?
Okay.
You understand?
Yes, 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 yes.
So at 20 units, 20 units down here, right?
Yep.
The buyer is willing, so you're looking again at the demand curve. At 20 units, the buyer is willing to pay 80,
Yes. So
all the way up here, right?
yes.
And so he's willing to pay 80, but it only costs him 50 right here. Now that still doesn't answer my question of whether I just subtract it or do I look at the area of the little triangle. I don't know yet.
Oh, okay.
But at least now I know.
I think I'm thinking you're gonna I think you're gonna do like it's 100 minus 80, right, Shauna?
That's what I'm thinking, that it's the little triangle. So it's gonna be like 20, but I want to check out more of the video and
Okay, yeah. Let's watch the video a little bit.
But does that make sense?
Yes, that makes sense. Yes, Shauna, that makes a lot of sense.
So let me see if let me open it again.
This for movie tickets to the consumer surplus equal to $160. The $160 of consumer surplus in this market represents the additional benefit enjoyed by consumers of movie tickets who get to pay a lower price than they're actually willing to pay. So let's now talk about producer surplus, which we'll first define. Producer surplus is defined as the extra benefit enjoyed by the producers in the market who sell their product for more than they were willing and able to sell it for. In this way, it's a lot like consumer surplus, except now we're talking about the suppliers of a particular product. To understand producer surplus, it's useful to think about the supply curve as not just a supply curve, but as a marginal cost curve for all of the producers in a market. So, for example, in the market for movie theater tickets, we would assume that there are perhaps dozens or maybe even hundreds of movie theaters competing with one another to sell movie tickets to consumers in this market. Therefore, the supply curve represents thousands of individual sellers, perhaps hundreds of individual sellers, each with their own marginal cost of providing movie tickets. Some sellers have very low marginal costs and would be willing and able to sell movie tickets at a very low price, perhaps of $3. As we move up the supply curve, we see there are more and more sellers who are able to cover the marginal costs of production and therefore are able to supply more movie tickets as the price increases. But along the supply curve, we must recognize that there are dozens, perhaps hundreds, of different firms whose willingness and ability to supply movie tickets is represented. Therefore, at a price of $8, there is additional welfare or additional benefits for all the firms who would have been willing and able to sell movie tickets at the price lower than $8. So if we shade the entire triangle beneath the equilibrium price and above the supply curve, which represents the supply from hundreds of different sellers, then we should be able to illustrate the area representing the total benefit or the extra benefit of all of the individual sellers in this market who would have been willing to sell movie tickets for less than $8. Of course, being able to sell movie tickets for $8 means that these firms have lots of extra benefit. Graphically, producer surplus is simply the area of the triangle beneath the equilibrium price and above the supply curve. We can just call this producer surplus. Therefore, we should be able to calculate the area of producer surplus when we have linear demand and supply functions, since this will always be a simple triangle. Let's do that now. Of course, the area of any triangle is 1/2 base times height. The triangle of the area representing producer surplus in our graph has a base of 40 movie tickets, a height of 8 minus the price intercept of 3, which is 5. So 1/2, 40 times 5 gives us a producer surplus of 100. In our graph here, we see that the producers of movie tickets will have a producer surplus equal to $100. In this case, this represents the additional benefit or the welfare of movie theater ticket providers who are able and willing to sell movie theater tickets at less than $8, but in this case are able to sell them at the higher price of $8. Clearly, a firm that's willing and able to sell a product for lower than the price it is actually able to is enjoying extra benefit or welfare. We call that producer surplus. So in our graph, we see that there is a consumer surplus equal to $160 and a producer surplus equal to $100. Finally, we should note that at the equilibrium price of $8 and quantity of 40,000 movie tickets, community surplus is maximized. To illustrate this, we can simply place a price of either greater than or less than $8 on our graph and see how surplus is affected. For example, at a price of $12, a greater quantity would be supplied of movie tickets. However, only 20,000 movie tickets would be demanded. Therefore, the consumer surplus in the market would be less, while the producer surplus perhaps would increase, but it's not exactly clear. We'd have to calculate the area of this.
You see what I mean? So what we have to do to find the answer for our answer,
Yes.
we have to go to 20.
Yes.
We have to find the little triangle. So it's going to be 20, and wherever the supply curve hits, you have to look at the supply curve, and where the supply curve hits our axis, it was parallel to it, and compute that.
Okay. So look at I'm looking at the 20, right?
So can you take a picture of it
Yeah.
and
Take
send
a
it to
picture.
my phone? Because I don't have the graph.
Like this, the one that we're looking at?
Just a graph, because I can't have the map without it.
Okay, so just I'm taking a picture right now. I'll text it to you.
Yeah, so I can
Okay.
see, this was helpful, no?
Oh yes, Shana. You know
This
that,
was
that's what the book, Shana. The book, it's kind of. I like those videos better.
but this video that was like super clear, don't you think?
Yes,
That
yes.
video was like you can't get much clearer than that, you know?
No, no.
Let me look to see where am I, because once I see the picture, then I can help you
Okay.
with the okay. So okay. So what we're gonna do? Okay, Carla dear, you took a picture of the screen.
Oh,
I
you
need
want, you want me to take a picture
I
of
need
the,
you to take the picture of the homework.
of the homework? Okay, no problem. I'll do
Because
it right.
I can, I can watch the screen from my screen. I don't have your homework.
You know what? I thought you wanted to go back and
No, that makes sense, but I need the homework so I can see what numbers you're supposed to use. That's
oh,
all.
I see. Okay, I send it to you.
It's
Sorry.
fine.
Sorry,
No,
Donna.
it makes sense, but I won't be able to use. Okay, so what we're gonna do
Yes.
is I'm gonna try and draw this. And remind me to show you the Google document, okay?
Yeah.
Before we finish. Let's see. So we have 0 to, you know what? I wonder if I can, give me a second. I'm gonna try something.
Sure, Shauna.
I'm gonna try and see if I can pull out something here. So I'm gonna say this is what? 100, and it goes through 100. Yeah, it goes through 100, and it's at 100. So it's basically y equals x plus 100 between, where's the curly braces? Between 0 and 100, right? 0 and, what is that? 0 and, yeah, 0 and 100. Between 0 and 100. And I'm going to enter that. And I'm going to check the window setting because I need this to go from 0 to 100. 0 to 100. And I'm going to get rid of the grid. 0 and 100. And I want to graph what is that problem? Oh, okay. I don't want a piecewise expression. I just want the angle. So I need a line, y equals x plus 100, and I need to go from 0 to 100, and I need this to go from 0 to 100 here. I need that to go from 0 to 100, and I need this to be y equals x plus 100. Actually, let me do 0 and
let me figure out what that is. So I have,
Take your time. No problem.
I'm trying to see if I can graph it on a bigger screen so that I can actually work with it.
Okay.
So that I have 0 and 100, and I have 100. Let's see, I have 0 and 100, and I have 0 and 100, 0 and 100. 0 and 100, and I have 0, 0. So this is going to be 100 over 0, 0, and 0 and 100. Wait a minute. So this line goes through 0, 0, and wait. This is 0, 0, and 100, 0. So this is going to be 0, 0, and 100. Oh, that's why. It's 100, 100. So I have 100 over 100, which is 1. And my y-intercept, oh, okay, gotcha. So I have, all right, that's fine. That's y. It's y equals x. But from 0 to 100. Okay, so there's my line there. And then my other line is y equals the opposite of x. So y equals the opposite of x. So then, okay, so this curve, where's the green one? Y equals negative x. So where is my curve? Oh, you don't like my negative, do you? That's why. You don't like the negative side? How about that? No? Why not? I don't know why you're having a problem. Hold on. Negative x. Do you not like it because of the keyboard? Or where's my negative sign? Plus, minus, ABC absolute value. Let me see. Exclamation factorial tilde. I wasn't having issues before, like negative x plus 100. Maybe it's negative x plus 50. I'm trying to see what the problem is with my range. Okay, there's my curve. Now let me bring this to 100 and see where my problem is at. It's 110, so that's 100 right there. Okay, so now let me see if this this helps you. I managed to do I did a little trick. Let's see if it works. So now, I'm gonna try, see if this helps. Because I just want a chance for you to see how I'm doing them so you can, so there's a picture we're looking at. Do you see it?
Yes.
Okay, so you have this now, this point here is 50-50. Let me label that. So this is 50-50. Okay. Now, this triangle, I'm going to draw in this line here. Y equals 50. Oops. So this line is y equals 50, right? ignore the rest of it, but this is your consumer surplus right here, right?
Yes.
Now, we want to know for 20, correct?
Yes.
So, I'm going to graph the line 20, okay? Now, you don't need the whole line all the way down. You need the line, because this is your curve, okay? You don't need all these triangles. So let me hide that line. Let me actually hide this line, the blue line, and give you back the black line here. So we're looking at this green, right? And we're looking at because this is equilibrium here, right? And at 20, we have two triangles. You see it?
Yeah.
This 20 is this vertical line here.
Yeah.
So the consumer surplus is going to be above the demand curve. So it's going to, consumer surplus is going to be this thing here.
Oh,
And we're going to find this triangle.
okay.
Okay? Because we actually have two of them, remember?
Mm-hmm.
We have this line here also, right?
Mm-hmm.
But we don't care about this line right now. Because we're looking at the consumer surplus. So the consumer surplus is going to relate to the demand curve. And the demand curve is the green one. So we're not looking at this blue one right now. We're looking at the line here. And we're looking at the 20. You see that? We're looking at that. So we're looking at the area here.
Okay.
Now, this is why I wanted to show you. So this is going to be, to find this height, this is 100 right here at the top, right? And this point is 80. So if I label this point here, that's the point 2080, yes?
Yes.
You see that?
Yes.
And this point is 100. So this is 20 units tall, right?
Correct.
And it's 20 units wide. You
Yes.
see that?
Yes. Yes. Yes.
So now take the area of that triangle.
Uh-huh.
That's 20 times 20, that's 400. And take half of that.
200.
So that's 200. And that's the consumer surplus at $20, which is what they asked for.
20 units, right? Or no?
20 units, right?
Bravo, Shauna!
Does that make sense?
Yes, that makes sense, Shanna. That makes sense.
And so now I think it asks you for the producer surplus, right?
Yes, yes.
So the producer surplus is going to be below, so we need the equilibrium here, right? Mm-hmm. So the producer surplus, I need to look not at the demand curve, but I need to look at the blue one. Yeah. So I'm going to turn the green one off, and I'm going to look at the blue one. Whoops, I need that. But I need the blue curve, which is that one. No, sorry. Which is?
Correcto, that one.
That one. Mm-hmm. So I need to give you the blue one right here. Now, how many units do we want?
How many units? We have for 20 units.
Oh, the same, 20, okay.
What is the seller willingness to accept? So I think we put 20, right? 20, 20?
He was, for 20 units, the seller was willing to accept 20, yes.
Yes.
Because the equilibrium was 50, but he was willing to accept.
Because now we're looking at the supply, right?
We're looking at the blue one right here.
Okay, yeah. Okay,
Right?
yes.
So we're looking at the blue one here. And so it's not this point anymore, you see?
Mm-hmm.
Because we've moved over here now. So now this is my point, right?
Mm-hmm.
So now I'm looking at the blue curve, and I'm looking at this point right here. This was 2080, right? So let me label these. This is 2080 for the first one. This is 2020, right?
Mm-hmm.
And so we're looking for the surplus of that, right?
Mm-hmm. 20, 30, 20, 30, 40, 50. I think that's gonna be height is gonna, isn't it the height?
At 2020, because it's 2020, right?
Yeah,
The height is 20, but the height from the equilibrium is 30.
correct, yes. And the base is only, what is the base?
Well, but here's the thing. If you use this, see, it's not a triangle. It's only a triangle if you're using the big one.
Uh-huh.
This green piece, that's what I'm a little bit confused on.
Uh-huh.
Because I don't know if I'm using the whole, see, I only used the little piece before, right?
Yeah.
So I'm thinking that we're just using this, but I'm not totally sure.
I think you're only using, my understanding, Shana, you're only using, because we only use, for the Consumer Plus, we only use the top portion, right? And I think
So I think we're only using from the purple to the blue to the end, which would make this 20. This would make this 20 as the base, and 20 as the height. So it would be the same. Because even though the prices are different, the triangles are equal.
I was thinking, and I could be wrong, but I was thinking the height, don't we have to go from here to the equilibrium?
Well, but the equilibrium from here to equilibrium, that would mean
30.
that you would be using this triangle, because this is not a triangle.
Oh, I see.
This piece is not like this piece.
Oh, I see.
It's not a triangle.
Yeah, you're
So
right.
I'm not totally sure about that. I'm not completely sure if you're using the 30 with the 20, and then here the 20 and the 20. If you're using the 30 and the 20, then you're gonna have 30 here as the base, right?
20 as the base, no, Shana?
Well, it goes from 20 to 50. So that's, if you're doing the base, it's going to be 30 units, because it goes from there to the equilibrium point. But it depends on which triangle you use.
Because I'm looking at the 20 to the 20, right, Shana? 20 to the 20.
So you're looking at this one here.
Yeah, so I'm looking at how
Then you would have 20 units as the base and 20 units as the height. Because 20 to 30, that's not a triangle.
Oh,
That, this, you mean? This triangle right here?
yeah, yeah, yeah.
But we didn't go to the equilibrium.
We didn't go to the equilibrium line before.
Yeah,
Maybe we should have, but we didn't. If we go to the
Oh, yes, you're
equilibrium,
right. You're right. You're absolutely right, Shana, because we didn't do that. Yes, yeah, yeah. I think if we are looking at the whole producer surplus, yes, but this is just for 20 units.
so
Yeah,
I think we would be looking at the small
Yeah,
one.
you're right, Shana. You're right.
It would
But
be 200 units, or 200, I mean.
But I get the same thing, 200.
Yeah, it's just a different triangle, but you get the same.
I see. Okay.
I'm not sure about that, but that's how you compute it, but I don't know if that's exactly
We'll
correct.
know, we'll know. I mean, I don't know. We'll know, I'll submit it in and then he's gonna let me know if we did it right or not. But at least we're trying. Shana, can you hear me? Shana, oh,
Oh, hi.
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 Hi. I think Shana is back, Samantha.
Okay, thank you.
Nice to meet you. I'm Carla.
Nice to meet you. She got disconnected, huh?
I think she did. She was helping me, and out of the sudden, it didn't. Yeah. How are you doing with your homework?
I'm studying for my test is tomorrow. Yeah, I know, I'm scared.
I know. That's calculus, right? Is that business call or that's
No, it's just Calc 1.
Oh, okay. I'll be taking business call hopefully next semester.
Okay.
Yeah, so I'll be in the same boat as you.
Yeah. I'm sure.
I'm taking economics. I don't know if Shama told you, but I'm taking economics.
Yeah, she did.
Macroeconomics, and I was just anything about numbers, anything. I just go to Shana, and I say, Shana, please help me. So she's helping me. I couldn't do my homework without her help.
Oh my gosh, I know she's very helpful.
I know.
Yeah.
But let me. You wanna text her and see if she's.
Yeah.
Yeah.
I'm here. Can you hear me?
Oh, you're here. Okay.
Yeah, I was furiously asking you to unmute your mic, and then I could hear you, but you couldn't hear me.
Okay.
Oh no.
You want me to unmute, Shana?
No, you're okay. Everybody's good.
Okay. If you want to talk to Samantha, it's fine, and call me back. It's up to you.
You can just mute your mic. Okay, so I'm gonna give you the same little lesson I gave Sam a little while ago.
Okay.
So on your screen,
Yes.
on the bottom of your screen where you have the options, where you have share and all of that,
Yeah.
go to the tab that says participants, and you should see a little icon that says raise hand. There should be a little raise hand icon.
Let me see, Shana.
It's like on the very bottom right corner of the when you click on the people right there.
On the participants?
Yeah, participants, and then you look at the bar on the right. It's like the right button on the right corner lower.
So go to participants. Go to participants. Go to the right hand corner at the bottom.
Okay, yes, got it. Okay, right.
And it has a little, so try it right now. And see, if I click, try it again. So there's your hand, right? So I see your hand raised. Raise your hand. So now, if I go to the hands, lower hand, and I can ask you to speak or whatever.
Okay.
You see what I mean?
Yeah, okay, so you want,
But if you send me a little signal that you raise your hand, then I know that.
okay, so you wanna, we only have 3 more, so you wanna work with Sam and then.
Yeah, I'm gonna get her back and then I'll come back to you.
I can stay here. Yeah, I can stay whenever you're ready. I'll be here.
You want me to? Yeah, just raise your hand when you need.
Well, you know, I need you. I need you.
I know, dear.
I just had
But
one small
She has a
question.
question.
Yeah,
so
well,
I
Yeah.
wanna-
Okay.
Yeah, no problem. So just
But watch remember you have the link in the chat, right?
yes, I'll watch it again. And
So
maybe-
you can watch that and then you can, okay?
okay, sure, no problem.
That'll keep you busy long enough for me to talk to her.
Sure, no problem. And when I'm ready, just holler at me, okay?
No worries. I'm
Okay.
gonna mute you temporarily, okay? All right, Sam, you're on. What can I do for you?
Okay. Okay, let me share
Sorry
my.
about that.
No, you're fine.
She's never used that feature, so I had to.
Yeah. Okay.
What's up? Oh, you have a nasty one, do you? Oh,
Yeah,
you got it.
well, I got it only because my friend sent me his answer, so I just tried
Okay.
his answer, but I have no idea how to do this
Okay.
one.
So if you're doing limits at infinity, okay, limits at infinity or limits at negative infinity,
Uh-huh.
and you want to divide, it's kind of like, remember in pre-calc, you were doing horizontal asymptotes and
Yeah.
you were looking at the ratios?
Yes.
What you want to do is,
Yeah, I know
you-
that you divide by the largest denominator exponent on,
you want to divide by the highest exponent, which is
yeah, which is t squared.
t squared.
And then the part that I got stuck was I had, converted radical t to the 1/2. And if I divide
Okay.
that by t squared, it becomes t to the negative 3/2. And then I
Okay.
get confused on how.
Okay, so let's walk through it. You're doing great. You're doing a great job. So let's walk through it really quick. So we have the limit as t goes, is it going to positive? It looks like it.
Yeah,
T goes
positive.
to positive infinity. And as you said, I'm going to write it as t to the 1/2, right? Plus t squared over 7t minus t squared, right? Now I'm going to divide everything by t squared. So I have the limit as t goes to infinity, and I'm going to write this as t to the 1/2 t squared plus t squared over t squared. This is 7t over t squared, and this is
Minus t squared over t squared.
minus t. Yeah, I scribbled it so hard I couldn't read my writing, which almost never happens to me. But okay, now before we get all up in arms about this term, this t to the 1/2 over t squared, right?
I think I see it. It goes to 0, huh?
Because exactly.
Oh, okay. I was thinking that, but I was like over analyzing.
You see why though?
Yes, because it's a really small number over a really large number.
Yeah, but I mean, let's do it the way you were trying to do it. So we have, don't worry about the rest of the fraction. What if I just gave you the limit as t goes to infinity, right? And I said it was t to the 1/2 divided by t squared. That would be the limit as t goes to infinity of t to the negative 3/2, as you said, correct?
Right.
Now that would mean the limit as t goes to infinity of 1 over t to the 3/2, right? As you said. Now,
Right.
infinity, a really big number that goes to a really small exponent, is still a really big number that gets really bigger, slower, really big.
Yeah.
Okay? So this term, the bottom is going to infinity. The bottom is going to infinity. The top is 1. So 1 over a really big infinite number is a fraction that's really small.
Yeah,
Okay.
so it goes to 0.
So that term goes to 0. So
Okay.
the limit of that first term is 0. T squared over t squared. Don't overthink this, okay? T squared over t squared is 1, right?
1. Yeah.
Because it doesn't matter where the limit's going. The limit of a constant is the limit of 1 is 1, you know? The limit of 2 is 2. Doesn't matter where it's going. Now, same thing here. Let's do the bottom term. We have the limit as t goes to infinity of 7t over t squared, right? This gives me 7 times the limit. 7 times the limit as t over t squared. That's 1 over t, right?
Yeah.
1 over t. Now, 1 over t is really big. The fraction is really small. 7 times infinitesimally small is infinitesimally small. So 7t over t squared goes to 0, correct?
Yes.
And then negative t squared over t squared
Is
goes
negative
to
1.
negative 1. So you have 1 on the top
And a negative
over
1.
negative 1, which gives you a limit of negative 1.
Okay. Okay, that makes sense.
Does that make sense?
Mm-hmm.
Do you have another question?
Well, I guess the one with the square roots
Okay. Mm-hmm.
is the ones that kind of get me.
Okay. So what we have to do here is now this is just a little bit of a logic issue because it's the same deal. Okay. What is the highest power of x present?
X.
More or less, yeah. I look at it like this. That's one way to think about it. But this is how I look at it. The highest power I see is x squared, right? But that x squared is under the radical, right?
Yeah.
So if you thought about the square root of x squared, the square root of x squared is the absolute value of x.
I was thinking about the highest powered denominator. That's what I was thinking about.
Well, that works too. But I mean, it works either way.
Yeah.
But it's either way, it's x.
Okay.
Right?
Yeah.
But what I typically do is I divide by, under the radical, I divide every term by x squared because the square root of x squared is x. And on the bottom, I divide every term by x. Because essentially, I'm dividing by the square root of x squared because that's the highest power I have.
So you're dividing the
So
square.
I would write the limit as x goes to infinity, right? And I would write I usually, if I have to divide under the radical, I leave myself extra room and I divide by x squared underneath it. So then I have limit as x goes to infinity of 3x over the absolute value of x minus 1 over, like so. I mean, it comes out the same, but this is how, when I did it, this is how I was originally, how I taught myself to do it.
Okay.
So let me show you what,
I think he did something like that in class.
I'll show you in a second. Let me just, I'm getting ready to show you what I'm doing here. I'm just gonna take a quick picture of this.
Okay.
so you can see what I did.
And did you not divide the radical x squared by the denominator then? As
I did, but you'll see. I'm
okay.
gonna send
Okay.
you a picture right now so you can, and then you can ask me questions about it.
Okay.
And hopefully it's not too dark. I might have to retake it because yeah, I have to retake that. That was like, that looks like I was in a closet. I swear I wasn't in a closet, but I have a lot of sunshine right now, and it just like took a shadow picture.
Oh.
I mean, you can see it, but it looks like, God, where was she? Was she in a closet when she?
Oh.
It does. It looks like I was in the closet when I took it. That's how dark it is. Like, did you shine? I mean, I would have gotten better results, I think, if I had shined a flashlight on the thing.
Oh, you're fine. I can read it perfectly fine.
No, but you'd be like, this is a bad picture. Can you please take another one? Because if I say it's bad, then you know it's like, I'm ashamed to say that I took that picture. It's so bad. But I don't even want to talk about how this is not much better, but it's a little bit better. It's a little better than the other one I took. Let me see how much. This is, yeah, you can see it. Not well, but you can see it. If not, I'll turn my back and I'll take it in. I only need the bottom portion. But I have the sun coming in through my window right now, and it's right on my paper, so it's like big light right there. Do you see what
Oh, yeah, I see what you're talking about.
I just wrote it differently at the bottom. You can write it as the square root of x squared, but it's essentially, it's the absolute value of
The
x.
value of x.
So
Okay.
if you're looking at the radical, the bottom, the denominator is getting big. So that first term under the radical goes to zero, goes to, let's see, that's 1 over x. So it goes to 0, right? 1 over infinity.
Yeah.
And then this term, so then you have 3x over x, that goes to 3, right? And that goes to 0. So I end up with that term. And I end up with 5/3. Square root of 5/3. Right?
Yeah.
Because that first radical goes to 0, and the second radical goes to the square root of 5, right?
Yeah.
And then the other goes to 1. So I left off the I put the x squared at the bottom, but I left off the x squared at the top. I copied it wrong. So put an x squared at the top of the radical, and then your x squareds cancel. You see it or not?
My x squared.
In the problem that I wrote, when I wrote it,
Oh.
I left the x squared off the numerator.
Okay.
Look at the problem that you have on the screen. I left the x squared off the numerator.
Oh.
You see it?
Okay, I see it. Okay.
They cancel, so I should get the square root of 5 over 3.
Okay, I was wondering about that. Okay. That makes sense.
Okay?
Yeah.
Does that help?
Yeah, so the x cancels with the absolute value of x. For the
Right.
Yeah.
Exactly.
Okay. Okay, that makes sense. It was a lot.
And essentially, because that x is going to infinity positive, that absolute value of x is just x, isn't it?
Right.
But I wrote it as the absolute value so you would remember that. It's going to positive infinity, so that's x.
Yeah.
Right? So it's just 3x over x, which is 3. And negative 1 over x, which goes to 0.
Okay.
Right?
Okay. And
how are we doing?
The next one, I would just multiply, or how would you do this one?
Well, if I'm doing, okay, so if I'm doing the limit there,
I'm not sure how they want you to write it, so hit the watch it and see what
Okay.
the watch it says.
I think,
But I think what they normally do is use the conjugate.
okay, that's what I was thinking, because I think he did the conjugate for this one.
Use the conjugate and then find the limit after.
Okay. All right. Thank you.
Because if you use the conjugate, it's going to be a polynomial term,
Okay.
right?
Yeah.
Because you're going to get 16 minus x squared plus x. Okay, so 16 x squared plus x, and then the end term is going to be the conjugate of it. So you're going to have positive 4x, right?
Yeah.
Which is going to get negative 16x squared.
Yeah.
So the 16x squareds are going to cancel. Are you doing it as I'm talking to you?
Yeah. Okay. Now I see it. Yeah. Sorry. I was just writing down the problem, so I was like,
Take your time.
okay.
Take your time. Are you okay?
Yeah. I'm good.
Okay. So now what do you have?
Okay. So I have the 16x squareds cancel. I have x over the radical.
No, you don't have a radical anymore. You shouldn't have a radical left. If you multiply by the conjugate, you shouldn't have a radical left.
No, I mean for the denominator. Don't you have to multiply it by the numerator?
In number 4, you don't have a denominator left. You just have there's no denominator in number 4.
Because don't you have to multiply by 1 technically? Like,
But in number 4, you don't have a fraction. In number 4, you don't have a fraction. You can write it as over 1 and then use both sides as the conjugate. Is that what you mean?
yeah, that's what I was doing.
Like if you have, so you're saying you did
Like radical 16x squared plus x plus 4 over radical 16x squared plus x plus 4.
plus 4x. Yeah,
Plus
that's
4x.
fine. Yeah, and then you're gonna have, so at the top, what are you gonna have? You're gonna have x, right?
Yeah.
And at the bottom, you have that radical term, right? So you're dividing by what? You're dividing everything by 4x, the radical of 16x squared, which is 4x. So you're dividing x by 4x, and you're dividing the other term by 4x.
Yeah.
And then you're doing the same thing we did before, right? Does that help?
So like this, in this case, when you're dividing, you're dividing everything by x.
The limit, let me catch up to you. The limit as x approaches infinity of square root of 16x squared plus x minus 4x over 1. So I'm going to multiply by the conjugate, which is 16x squared plus x plus 4x. And on the top, I have the radical, the conjugate, 16x squared plus x plus 4x. And so when I do that, I get the limit as x approaches infinity of 16x squared plus x minus 16x squared over the square root of 16x squared plus x plus 4x. Now, the 16x squared on top cancels, so I have the limit as x goes to infinity of x over the square root of 16x squared plus x plus 4x.
Mhm.
Now what I want to do is I want to divide both terms in the top and the bottom by the square root of 16x squared, which is 4x, basically. So the limit as x goes to infinity of x over 4x divided by,
So you're dividing everything by 4x, not just x.
right, because the highest power that I have present now is, well, it's the square root of 16x squared, right? And what's the square root of 16x squared? 4x, right? The highest power of x present is x, so you could divide by x if you want.
Okay, because I didn't know if we have to include that.
Well, 4 is not going to matter, but I always learned that you include the constant. So
Okay.
just do it the way he's doing it. Do it the way he's doing it, but I always included the constant.
I just don't think he gave us a problem with the constant.
It's not, the 4 is not going to matter.
Okay.
It's not going to change the, because 4 times infinity and infinity are not all that different.
Yeah.
It's not going to change the number.
Okay.
You're gonna, because the x's are going to cancel in the numerator anyway, and you're going to get 1/4, right? And the x on the bottom, you're going to get 1 plus, that's going to go to 0, so you're going to get square root of 1 is 1 plus 4x. So that's going to be 1 plus 1. That should be 2, right? If I'm doing it right. I haven't done the math, but does that make sense?
So when you're dividing the bottom, you're dividing it by x as well.
Well, I would divide by 4x, but if you're dividing
Oh,
by
4x.
because I'm doing 16x squared plus x divided by 16x radical 16. So this is, yeah, so that's 16x squared under the radical. And then here I'm dividing 4x by 4x. So
Okay.
I have the limit as x goes to infinity. X over 4x means I have the x's cancel, right? And I get 1/4 at the top, and I get, this goes to 1, this goes to 0, and I'm getting 2 at the bottom. Is that what you're getting?
I don't know. I'm not getting x.
Because if x goes to infinity, and I'm dividing by x, then that first term is going to go to 1, right?
Mm-hmm.
And then the second term under the radical goes to 0. Watch the video and see what happens.
Okay. Yeah. I'll do
Watch that one and see what happens. But I think that's how it works.
Okay.
Okay?
right.
Back. I'll stay on for a while yet.
Okay.
But I want to get back to Carla and help her with those last couple of ones.
Okay.
But watch the video and come back to me, okay?
Okay. Thank you.
And with any luck, my internet will stay connected. But remember, call me if you...
Okay. All right.
But it's pretty good at this time of night. So I'll be here for a while.
Okay.
Okay?
All right. Thank you.
All right, Sarah.
All
You're
right.
welcome. Anytime. Hey. Unmute.
Hi, Shauna.
There she is.
Hey,
Let me...
hey, quick question, Shauna.
Yes,
how do
ma'am.
how do I unmute, like when you're in another session, how do I unmute it?
How do you mute your mic? Should be
No,
on the
like,
lower left.
How do your conversation with another student.
Lower left with your microphone. Lower left-hand corner, look for your microphone icon.
Uh-huh.
You should see your microphone icon.
Yes, I do.
Click on your microphone, and now you're muted. Open it. Can't hear you.
Okay, so
There you go. Now I can hear you.
yeah, like I know how to unmute it on myself, but how do I unmute it when you're talking to another student?
So you don't want to hear what you mean?
No, the thing is that I wanted to listen to the video just in case. It doesn't bother me, but just in case I needed to listen to a video, like the video that I was gonna watch.
If you make sure that your mic is off, then we won't hear background noise. If you want to silence it, you have to douse your speaker and listen with headphones or through your speaker device.
Oh, okay. Got it. Okay, next time I do it. Okay.
Does that make sense?
Yeah, that makes sense. Yeah.
I was actually wondering the same thing because I wanted to watch a video too.
Right?
Yeah, I can't listen. The video and you talking happens at the same time.
I see. Yeah.
Yeah, so
Well,
I can't.
you can remember that you can exit. You can always exit and come back.
Okay.
So if you don't have because now that's not true for every meeting, but when I set my meetings, some hosts will set their meetings so that if you exit, you can't come back. But I never.
Okay, I see.
But I never do that.
I see.
So like if Samantha, go ahead, Samantha. I'm not picking you out, okay? Go ahead and because I want to show her something. Go ahead and leave the meeting.
Okay.
And then come back, so I can show her how it works.
I see.
So you can exit, right?
Yeah, she left already.
Now she's gone. Now if she wants to come back, she should be able to click back in. She has to click the link again.
Oh, okay.
And then she'll be able to come back. See, now, did you hear the doorbell?
Yeah.
Right now, she's waiting, and I can admit her back.
Oh, cool. Okay, I'll do that next time.
If you don't have an external, thanks, Sam, for that.
Sure. You're welcome. Okay, I'm gonna leave again.
So if you don't have the external speaker or you don't have the device, you can leave and come back.
I see. I was just wondering, I mean, I can always,
these are things that they don't tell you, like, when they train you, they don't tell you.
Oh,
but
I see.
It's important to know that.
Yeah, I know. Yeah. Okay, that's good.
Well, thanks for letting us take that hiatus, Carla.
The what?
Thanks for letting us take that hiatus. I had to help you.
No, I love it. I love this thing, Shauna. I really like Zoom. I'm not an expert as the same as you, but I love it. I mean, you can do anything.
Yeah, the only problem, like I said, sometimes my internet connection gets a little.
Yeah.
But it works.
Yeah, it does.
Anyway, so did you figure out what was going on?
I did. I figured out one, but I just need help on E. I don't know if you
Okay, let me look at the picture again. And
okay.
I'll see what I have. Yeah.
Okay.
Let me plug in my phone. And you know how to use the chat to pick up the link from the chat, right?
Yeah, I know.
Okay,
yeah.
You know how to do that. Okay, good.
Yeah.
Because that's the other thing I do if I get disconnected is I start chatting like cuckoo. Like, are you okay? Is everything?
I see.
So,
okay. Thank you, Shauna, for giving me the Zoom tour.
No problem. It's just those little skills that you need to know.
Yeah, definitely.
That they don't tell you. Like, it would be nice if somebody told you that,
Yeah.
Okay, so E, for 20 units, what is the seller's willingness to accept? And at 20 units, will this trade take place? I have no idea. At 20 units, will this trade take? I don't know if
You think it's based on the answer that we did for D?
probably, but I don't know the rationale behind it. So what I'm going to do is I'm going to say, now you asked me about how I search. So this is how I do it. I go to, I'm going to share my, well, before I do that, I'm going to open up my screen here. And we're going to, I'm going to share my screen here. And now I want to know my screen.
Yeah.
Okay, so I'm going to go to the bar up here and I'm going to put in given a consumer surplus and a seller's surplus at some point, how do I know a trade takes place? I'm going to see if that gives me anything. Sometimes it does, sometimes it doesn't. Let's see what it gives. So I'm going to wait for it. Consumer surplus introduction, producer and surplus, supply and demand. How do you find consumer surplus? Consumer versus economic surplus. Practice questions and answers. Okay, so let's take a look at this. This looks similar. So let's take a look at this and see if this gives me anything. Let's see if this says anything here. So it says, determine the amount of consumer surplus, blah, blah, blah. Okay. Leon goes to the clothing store to buy a new t-shirt for which he is willing to pay up to $10. He picks out one that he likes with a price tag of exactly 10. When he is paying for it, he learns that the surplus has been discounted by 50%, right? So he's willing to pay 10. The price tag says exactly 10, so he's at equilibrium at that point, right?
Yes.
But then he goes and it's been discounted by 10%. So that means he's only going to pay.
It's been discounted by it's been discounted by half. So now he's only going to pay $5, correct?
Yes.
So his surplus is $5.
Mm-hmm.
Okay? So Leon's consumer surplus is $5. That is the difference between how much he's willing to pay and how much he does pay. Since Alberto's willingness to pay is now, here it says he goes to the CD store hoping to find a used copy of Nirvana's greatest hits for up to $10. The store has one copy selling for 10, which he purchases. Then he doesn't have a surplus. He's at the equilibrium. He's not getting any additional benefit from it, right?
Mm-hmm.
Now, this is the one that we wanted to think about. After soccer practice, Stacy is willing to pay $2 for a bottle of mineral water. The 7-Eleven sells mineral water for $2.25. So she declines to, because she's only willing to pay $2.
Mm-hmm.
And they're selling it for more than she's willing to pay. So no trade takes place because Stacy's willingness to pay is less than the price. So if the price is higher than your willingness to pay, you won't want to pay for, right? In your case,
So less,
And you're-
so less price means consumer surplus, Shana?
well, what it means, consumer surplus is when you're willing to pay something for something and you actually find it for less. So, like in the last example that we did, we have 20 units, right?
Yeah.
So the consumer was willing to pay $80 for it, correct?
Yeah. Mm-hmm.
And so the consumer was willing to pay 80. The equilibrium was 50, right? So the consumer surplus was the area that we created. And so that, but the difference between them was at 80 and at 50, that's the difference of 30 units, isn't it?
Mm-hmm. Yeah.
So for 20 units, what is the seller's willingness to accept? At 20 units, the seller is willing to accept 20, isn't it?
Yeah.
So the seller is willing to accept 20 and the consumer is willing to pay 80, right? So
Yeah.
yes, a trade will take place at 20 units. A trade takes place because the consumer's willingness to pay is greater than what the seller will accept.
Is greater than what the seller is willing to accept.
Mm-hmm.
Okay, so let me just, okay, I see. Okay, sellers willing to accept, and then, okay, I see. Okay, so it will take.
Because the seller, if so I'm selling a product that I'm willing to spend, that's it. So let's think about like a garage sale, right?
Mm-hmm.
I have this item and I just want to get rid of it and I want to sell it for $20, right?
Yeah. Mm-hmm.
And you know what you're really looking at. I don't care. But the
Yeah.
seller comes and he's like, oh, that's a bargain. That would be a bargain for $80. Let me go offer them $80, right? Obviously, there's a trade that's going to take place.
Okay.
Because
Okay.
I'm willing to accept 20, right?
But you're willing to pay
But
80.
you're willing to pay as much as 80. Now, does that mean you're going to give me 80 if I charge you 20? No. It means that you're willing to pay more than I'm willing to sell it for.
I see. I see.
Right? Here's an example from my own life, right? I used to charge $10 an hour for tutoring, right?
Yeah.
And I had somebody call me, true story. I don't know where she got this information, but she called me up and she was giving me this whole story and she was going on and on and on. And I finally we got to fees and she's like, well, I'm willing to give you $100 an hour. And after my chin fell off the floor, I was like, well, first of all, there's no need for that. Like, I don't charge anybody that amount. And really, you don't need that. I mean, it wasn't that big a deal. It was probably going to take like a couple of sessions to help her.
Mm-hmm.
And she goes, I heard that your fees were $100 an hour. I said, I want to know where you got your information because that's completely wrong.
Mm-hmm.
But see, of course, she was going to accept my services.
Mm-hmm.
You see, because I was willing to accept 10% of what she was willing to pay.
I see.
Do you see?
Yes.
Now, for 70 units, what is the buyer's willingness to pay? So you go to 70, you look at the bottom graph, it looks like 70.
30, right?
Roll it up. It looks like 30 to me, yeah.
30. Okay.
For 30, yeah, 30.
Yeah.
the buyer's willingness to pay is 30.
Yes.
And for, I don't know, I don't have a picture of anything under that, so I don't know what comes after.
Okay, so it says for 70 units, what is the seller willingness to accept?
Okay, so the seller will accept, you look at the supply curve, the seller here wants 70, doesn't he?
Yes.
So the seller wants 70. The buyer is only willing to give him 30, right?
Is that for G?
I don't know because you only took a picture up to F.
Yeah, so so for G it says for 70 units, what is the seller willingness to accept? So I put the answer, I put 70.
That's correct.
Yeah, okay. And then H, it says at 70 units, will this trade take place? I think so, right, Shauna?
Okay, now what's different about this than the other one that we did?
Because it's like, it's where, I'm thinking it's where the equilibrium meets, like.
Well, no, this is not equilibrium anymore.
No? Okay.
Because equilibrium was at 50, remember?
Oh, yeah, you're right, yeah.
So go to 70.
Uh-huh.
Right? How much, now, if I'm looking at the seller, right? Which curve am I looking at?
You're looking at the supply.
Right. So how much, like, let's say I'm giving you tutoring services. How much do I want?
Okay.
At 70, how much do I want?
Okay.
Go to 70.
So you want 70.
I want 70, okay?
Yeah. Uh-huh.
So Shauna wants 70, okay? Now, if Carla is the consumer, which curve is Carla on?
I am at the demand, right?
You're on the demand curve, right? And for 70, how much are you willing to pay me?
30.
Now, if you're only willing to pay me 30, and I want how much?
70.
Then are you gonna buy it?
No.
No, because you aren't willing to pay that much. So no trade will take place because the seller's price is more than what the consumer is willing to pay. Does that make sense?
Yes, consumer is, yeah, is willing.
That's very much like the situation that we just read with Stacy, right?
I see.
So
Okay.
your willingness to pay, the consumer's willingness to pay is less than the seller's price.
Okay.
And so you don't create a consumer surplus in that case.
Okay. Yeah.
You don't create a consumer surplus in that case.
Yeah.
Now, in the other situation at 20 units, right? You want 20 units from me, right? How much will I accept for 20 units?
For 20 units, how much?
How much I accept this for 20 units?
The buyers will it will accept 20, right?
That's what you that's what I'm willing to accept. How about you? You're
80.
willing to pay how much? Yeah, so
80.
in this case, the price is less than what you're willing to pay. So there's a consumer surplus that's created.
Nice.
You're getting more than.
We did it, Shauna. We did it.
Does that make sense? I don't know about the other, a couple of those, but that's pretty much how it works.
Yeah, I think so. I think we can do it, Shauna. I think tonight I'll take the quiz. See how I do it.
How many attempts do you get? 2?
2, yeah.
Okay.
So I'll try to do it on my own, and if I don't get a higher points, I'll try to text me tomorrow.
Yeah.
When are you available?
Yeah, tomorrow I'll have more time.
Okay,
So-
awesome.
So tomorrow, but I want to show you something before you go.
What's
Okay?
up? Yeah, sure.
I want to show you this, but first I have to open the file, and it would really help me if I actually open it first. Funny how that works. So I wanted to share the Google Doc with you. What is your email, your personal email? What is it?
It's Carla,
Okay.
M like Mary,
Uh-huh.
A like Apple,
Uh-huh.
R like Robert,
Uh-huh.
T like Tom,
Uh-huh.
14
Okay.
at yahoo.com.
I remember that email at
I
Yahoo.
think so. I think so.
Carla Martin at Yahoo. I remember that.
Yes.
Yahoo, right?
Yeah, so what I'll do, I'll copy, I kind of go through what you did.
So now, okay, so here's the thing, okay?
Uh-huh.
I shared this Google Doc with you,
Uh-huh.
okay? I shared it.
I don't see it, Shauna.
No, I'm gonna share the screen right now, but I shared
Okay.
it to your email, okay? This Google Doc is in your email, okay?
Uh-huh.
And it's shareable. I shared it, see? So I set it up to where, okay, so Carla Mart 14 at yahoo.com. I want to fix this. So I want to set the setting to, okay, share with people setting right. So now, change to anyone with the link. Change sharing options. Click restricted to change link sharing. No. Okay, so now anyone with the link can share it. So what I'm going to do is I'm going to, just to make sure, I copied the link. Now I'm done. So anyone with the link can have access. Now what I'm going to do is, you should see it on your screen right now.
Yes, Shauna.
Now, I also sent you pictures of the notes that I took, but this is part of the stuff that I did. So the first learning objective in there was analyze the economic impact of price ceilings, right? So I went to the video that was on price ceiling, the one that you watched, and I wrote out what it is. A price ceiling is a government intervention that establishes the maximum price that can be charged for a product or service. Price ceilings help consumers by lowering prices and making products more affordable. Price ceilings set such that they are below the equilibrium point of a market will be binding. So that's important. Below the equilibrium point will be binding. This intervention will affect the market by creating a shortage. So price ceilings below the equilibrium point are binding. Price ceilings that are above the equilibrium point are non-binding. They don't have an effect on the market.
Shauna, and you type all those notes?
Well, so what I did was I put in the learning objective that was there, and I typed the notes into the Google Doc.
Wow. Okay, that will be very, I think
And then a price floor is an intervention, but this is how you do it. A price floor is an intervention that, and you follow, and this is just from the video. So that establishes the minimum price. Okay, so that establishes the minimum price. And I just got this from the book and the video, basically. Okay? That can be charged for a product or service. Okay?
Mm-hmm.
And then you continue with that. Now we know that price ceilings are set if they're high. I'm sorry, a price floor that's high is not gonna, a price floor that's high is gonna have a binding effect. A price floor that's low is not, because it's gonna create a surplus.
Mm-hmm. Okay.
Do you see how it works? And
Yes,
it relates
yes,
to the
yes.
objective. I mean, you don't have to be that detailed, but the thing is, every time I read something or I hear something important, I put it in under the heading of the objectives. And by the time I go through the material,
Then I have all the material that fits under all the objectives, and I only have to do it one time.
That's wonderful, Shauna. That's wonderful. What
It's a lot of time on the front end, but like I can, if I copy, so honestly, what I would probably do, because I just started this today, is I would go to the first module where it gives you the objectives for the module, because it does. It gives you all the objectives, copy all the objectives into a document, and then start going through the module. And for everything in the module that fits an objective, you write notes under it.
Okay, I will do it, Shauna. Cause I'll be taking my midterm in 2 weeks.
Uh-huh.
Yeah, okay, that's good. That's awesome.
But does that help you? See what I'm
Yes,
talking
yes,
about?
yes. I think so. Yes, definitely.
You don't write every single little, you don't write every single little thing. You just write, so like I might write like under here, I might write see video. Or if there's a page in the textbook, I might like page so-and-so in the text, you know what I mean? So I can go back if I need
Okay.
to look at a diagram. But this is not much. This is just blurred, but I need to know what a shortage is. I need to know what a price ceiling is. I need to know what a
That's true.
price floor
That's
is.
true. That's true. Yes.
So I'm not writing
That's
pages and
awesome.
pages. I'm not writing pages and pages, but I am covering the objectives.
Yeah, that makes sense. That makes a lot of sense.
But
Shauna.
that's how you would study. Because the thing is when you read the textbook, it's under the objectives, but it's not always apparent because they mix it. You know what I mean?
Thank you, Shauna. That's wonderful.
And sometimes it's repeated. So start with the objectives. And as you read the material and go through the activities, then you can understand what this is.
Okay.
Now, the example for price floors is minimum wage. Minimum wage is a price floor. You can't set your price below that, because there may be a few people willing to work for, let's say you're, like the video said, let's say you have people willing to work for $8, but the minimum wage is $12, right? So what you have is you have a surplus of workers.
Okay.
You have too many workers, so you create employment in that case,
I see.
essentially. Because you have more people that want to work, but can't.
Okay.
So you create a surplus. That's not the only way, but that's, in this case, that's how it's created. Does that make sense?
Yes, Shauna. Yes.
And this is a shared document, so that means you can go into this document if you want. Like if you study tonight and you see, oh, I'm reading about, say, how to compute CPI or CPX or whatever, right? You can write in another objective in here.
Okay.
And you write the objective under the numbers, and then you write the details under the letters.
Okay, Shauna. Wonderful.
Does that help?
Yes, yes. I'll continue. I'll try to go back to the first module, second module, and do how it is. Yeah, and then moving forward.
So I hope that was helpful to you.
Yes, very helpful, Shana. Very helpful. And then we'll talk tomorrow.
Oh
And
yeah, no, I'll have more time tomorrow.
yeah, no, this was wonderful, Shana. Thank you. We did.
I hope it's correct. I'll have more time to look at it and see if it's correct or not. Okay?
Yeah, that's fine, Shana. And then I want to talk to you about your fees. Would it be okay if I paid you? Oh, Sam is back. Maybe he needs help.
Yeah, talk to me tomorrow.
Yeah, we'll talk tomorrow. Yeah. Okay. Thank you so much.
All right. You know
Okay,
how
I'll
to
see
leave
you.
and come back? I said, now you know you can leave and come back, okay?
Yes, definitely. Good night, guys. Okay.
I'll set up tomorrow to let you guys both know. I'll set up a meeting early, like, tomorrow, yeah. I can set up a meeting at like 8, and I'll just leave it open.
Okay.
So
You mean 8 a.m.?
Yeah, I'll set up a meeting at 8.
Okay, because I usually go to work and then I'll come back, but I'll try to
But Sam is here. So.
Yeah, Sam is there. Yeah, okay. Good luck, Sam, on your
Thank you.
test tomorrow.
Thank you so much.
Okay, bye-bye. Bye.
Bye.
Good night, guys.
Bye, Carla.
Bye. Thank you, Shana.
Welcome. Thanks for that, Sam.
Yeah. No.
How are you
sorry.
doing?
Good. I'm still a little bit stuck on that, that last problem we were doing together. I watched the video.
The limit? Okay, sure. Let's go through it. What were you saying? Keep talking to me. I'm listening to you.
Okay.
I'm just getting more paper right now. That's all. Because math takes a lot of paper, right?
So I understand, the way that they did it, because they
Do you want to share your work?
yeah, should I take a picture and send it to you?
You can take a picture, or you can screenshot it however you want to do it, whatever you.
Okay, I'll take a picture because I did it on paper.
Oh, okay.
Let me just, sorry, I messed up on these, so let me just scribble these out. It might be a little messy. I'm sorry.
Sure. No, don't worry. I've sent you plenty of messy work. As long as we can read it at this point, I don't think we have to worry too much.
Okay.
Thanks for letting me help her. She was almost done. So.
Oh, yeah, it's no problem.
Like I said, hopefully it won't be like this every week. Maybe I can stagger you guys a little bit more. But I think we'll be good.
Yeah. Because as long as, I have other mechanics, just understanding the mechanics of everything.
Yeah.
Yeah.
And I'll start the meeting at 8. So if you want to come in and then go out and then come back.
Okay.
Or call me. I'll leave my phone open. So just be like, hey, pay attention. I'm raising my hand over here.
I know. I probably should have said, but you were in the middle of a problem, so I didn't want to interrupt you.
No,
And then
okay.
I turned my.
It's not invasive because I don't have that set to give me a. Did you send me something? Or not
Oh
yet?
no, not yet. Sorry, I didn't write down the problem on this. But.
Yeah, but I have it. It's the square
You have
root.
it? Okay.
Square root of 16 something squared. Let me look for it because I have it written.
Okay. Sorry, I just have because I put it on 2 separate sheets and
No, that's fine. No problem. You hire me to do complicated stuff like this. It's
I know.
fine. It's fine. You also hire me to Zen talk to your anxiety. So I get that.
Yeah.
I'm fine with that. So the problem is the limit as x goes to infinity of the square root of 16x squared plus x minus 4x. That's the problem that you were given.
Yes.
Okay. Now, did you send me the picture yet? Or
Yeah,
not?
I sent it, so hopefully you got
Let
it.
me take a look. Oh, yeah, there you are. I have like a bajillion notifications. Let me clear them out. So, okay, there it is.
So they divided everything by x, which she had explained step by step on another problem
Okay.
where she combined those two x's to become a radical x squared.
She
Do you
combined the two x's.
like underneath the 16x squared and the x, she combined that fraction all under one.
Okay, so she basically got a common denominator, basically, is what you're saying.
Yes, and I don't understand how it is it because she puts a radical x squared because it's going to go under the radical, or why does she do that?
Okay, so 16. Okay, so you understand how we get rid of the numerator, or do you want me to go back? Do you want me to go back to
Oh
the
no, I understand
beginning?
yeah,
You
no.
understand where 1 came from,
Yeah,
right?
I get it up to this point.
Okay, so now, so under the radical, after you multiply by the conjugate, because the conjugate of this, as you said, remember that's how we got the bottom of the fraction. So the limit as x goes to infinity, right?
Mm-hmm.
And we're going to multiply both sides, which I have to do because I didn't write that down yet. So I'm just going to do that really quick
Okay.
so that you have it. So this is 16x squared plus x minus 4x, and I'm multiplying by the radical of 16x squared plus x plus 4x. Now on the bottom, everything, those first two terms are under the radical, correct? 16x squared, and I have
X.
plus x. Now, I'm dividing here by the square root of x squared, which is x, yes?
Yes.
That's what she's saying. Now, if I divide that, okay, then I have to get a common denominator for those fractions. What is the common denominator that I'm trying to get?
Well, it's x, isn't
It's
it?
x, right?
Yeah.
So the 16x squared has an x already, right?
Mm-hmm.
But the x doesn't. So I had to combine it to get that because I have 16x squared plus x plus 4x, and that's all there. So now I have to get a common denominator underneath. I'm dividing by x. So then I have, now what she does, the next thing you have written down is what she does on the bottom after she gets x is she takes that radical on the bottom, 16x squared over x plus x over x, right?
Mm-hmm.
And what she does is it's all over the same denominator. So that's really like writing the square root of 16x squared plus x over x, correct? Now,
Yeah.
what she can do, because what is allowed under the radical, if I have a fraction under a radical, I can make that two radicals, right? So what she did was she took the numerator, which was 1,
Mhm.
and she took the denominator and she made it a complex fraction. So she said that this was equal to the square root of 16x squared plus x and the square root of x on the bottom, because she split the fraction. Because when you have a denominator, right, she wrote that as the square root of x squared.
Yeah.
So she split it. So she had the square root of 16 plus x squared, and she wrote the denominator, instead of writing x, she wrote it as the square root of x squared.
Okay, so when she does that,
Uh-huh.
she makes it like into two separate fractions.
Right,
But
exactly.
isn't the x technically under the radical already right now?
Right, it is under the radical. What she did was, it's a double manipulation. So
Oh,
what
okay.
she did was, if you look at the second step on the right, I think the second step on the right would have made more sense if you had added one more step, which is under the radical, if you combine the first two fractions,
Mhm.
you get 16x squared plus x
Mhm.
over x, yes?
Yeah.
Now, think about, that's a fraction under a radical, right?
Yeah.
So I can write that as the fraction, which is the square root of 16x squared plus x, right?
Mhm.
Now, here's the thing. She's got the square root of x,
Oh, I see.
but you've got the square root of x there, but it doesn't matter. You don't have to use x. You can use x squared as your denominator. And that's what she did.
Oh.
Because the square root of x squared is x.
Oh,
And
okay.
she did that just to make the fraction cancel.
Okay.
Does that help?
Yes. Okay. Thank you.
Does that help or not?
Yeah, it does.
You
Yeah, that
understood
was
that?
just the one part I was like,
No, I can imagine. It looks a little weird when it's not a calculus thing, and it's not really even a common denominator thing. It's an algebraic renaming.
right.
You didn't even, I mean, you got a common denominator, but you're right. You had already done it.
Yeah.
You had already gotten the common denominator already. That's true.
Mhm.
Okay. What you're doing is you're renaming the common denominator
Okay.
in a different way.
And that's like basically in order to get that x over the x squared so that it
Right.
can become
Exactly.
0.
Yes.
Okay.
It's a manipulation so that you can actually find the limit.
Okay. Okay.
Yeah?
Yeah. Thank you so much. I know it's already past your time, so
No, I'll give you a few more minutes. It's fine. I can go till 8:30. So
okay.
I
I
have
just
a couple minutes.
I just wanted to really quick maybe go through a question in 2.8 if we could.
Yeah, for sure.
Okay, you have time for that?
I think so, yeah.
Okay, because I know this.
Yeah, that's fine.
Okay.
Yeah, that's fine. I can push it to 9 if I have to. I just don't like to push it right up to 9 because it takes me a while to get ready. So,
Yeah, and you've
but,
been up.
but today, under the circumstances, I think, tomorrow. I already told Doris, like, I'll talk to you later, like
Yeah.
later. Let me just get, Sam has a test, you have an essay, Carla has a test, so
Yeah, it all
right
happens.
now my philosophy is baby step to Thursday afternoon, because Thursday afternoon it all blows up and we all turn into mice if we don't get home before midnight.
Mm-hmm.
So, no, it's fine. We'll be okay. Which one do you want to look at?
So I think the water tank one, maybe,
Okay,
or
there are two of them that
yeah.
I know of. There are two that I gave you, or there's one on the review also.
Oh yeah, maybe we should do that one then. Okay. Let me pull that up then.
There's one on the it might be the same. I don't know. Might be the same one.
Yeah, that'd be good for practice. Yeah. Okay.
And
Let
we have the
me.
answer, so we know if we're right or not.
Yeah.
I was telling Professor McDowell about the one that took me an hour and 2 pages to write. I go, yeah, it took me like an hour to do that one. And I said I had to go look it up in the book, and I had to watch the video, and I had to do the problem after that. And then I was like, okay, that's too much. So she said that she said send it to me. She wants to look at it, and then she and I are gonna go over it later.
Oh, that's nice.
Just because I told her I mean I did it, but I don't think I could explain it if you paid me. I told her like, I did it, but explaining it is another whole. All right, so let's see what it says. A water tank in the shape of an inverted circular cone has a radius of 3 meters and a height of 6 meters. If the water is being pumped into a tank at the rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 4 meters deep. Okay, so it's very similar to the ones that we did before.
Mhm.
But it's a little bit easier than the one on Cengage because they left all the units consistent.
Yeah, he said that he was going to do that on the test.
So because the one on Cengage was another reason why that was hard, was
Yeah.
because there was that extra piece of doing that. Okay.
Okay.
So the first thing you want to do is write the volume formula down.
Mm-hmm.
Volume is equal to 1/3 pi r squared h. Now, then we want to write down what they give us. A water tank has the shape of an inverted circular cone. Okay, we took care of that. With a base radius, and here that means the big one at the top, the base radius of 3 meters. So we know that r is 3 meters, okay?
Mm-hmm.
And now, the important thing about this is that's the base radius of the cone. That's constant.
Yeah.
Okay? That's constant. So this is another thing about this problem that gets confusing. What's constant and what's changing? But that's constant.
Okay.
And a height, we're talking about now. The other thing that's confusing in this problem is the height of the cone and the height of the water.
Right.
Okay? The height of the cone is fixed. That's a constant. The height of the water is changing. So the height of the cone is a constant. And that is 6 meters. Okay?
Yeah.
If the water is being pumped into the tank, so the volume of the cone, water is being pumped into the tank. So I'm going to say dV dt, because water's going into it. This is a rate at which the volume changes,
Mm-hmm.
is 2 cubic meters per minute. So I'm going to write 2 meters cubed per minute, positive, right?
Yeah.
Now, we want to find the rate at which the water level is rising. Now notice here he made it also a little easier because there's no hole. Remember the one we did had a hole in it? This
Yes.
one doesn't have a hole.
Okay.
So there's no water going out of it.
Okay.
So that's another thing. So dVdt is 2 meters, right?
Mm-hmm.
And we want to find the rate at which the water level is rising. So we want to know, now we want to know the other h, not the height of the cone. We want to know the height of the water. dH, dt. We want to know the rate at which the water, when the water is 4 meters deep. So the height, we want to know when the height, when h is 4 meters. Now we need to know more than just that, but we need to know how fast it's going when h is 4, right?
Yeah.
Okay, so let's do this. Let's notice something here, okay? Now, we don't know, if you look at this function, v, right? If I try to differentiate this right now, right, then I have an extra variable in here. I have r, right?
Mm-hmm.
Now, r is constant, but the volume of my cone is changing
Mm-hmm.
with respect to r, right?
Yeah.
So what I need to do is I need to find a relationship that relates the radius to my height, okay?
That's the volume formula?
Well, in the volume formula that I have,
Uh-huh.
I need to get, in other words, I need to get rid of that in my equation in order to be able to solve the problem. Because I don't have a change in the radius.
Right.
They give me the radius of the tank, they give me the height of the water, but I need to get rid of r. I need to get rid of r. There, okay? I don't have any information about dr dt. Now, why is that important? Because as the water level rises, right, the radius of my circle changes.
Mm-hmm.
Yes, it's 3 meters at the top, but it's not 3 meters in the middle of the cone, is it?
No.
So I need to get rid of r. So because I don't have information about r, or specifically dr dt, right?
Mm-hmm.
I need to get rid of r. Now I can't just make it go away, right? What I need to do is I need to write r in terms of my height, right?
Oh, yeah.
So what I'm going to do is I'm going to write r in terms of the height. Now, we know that r is 3 meters, and we know the height is 6 meters, and those are fixed. So the level is not the same, but the ratio is the same all the way up the cone, isn't it?
Yeah.
So I can say that my radius is 3, my height is 6, so I can say that r is half of the height. R is 1/2 h. Do you see that?
Okay, yes.
Okay, now, if R is 1/2 h, Then what I'm going to do is I'm going to rewrite my volume formula. I'm going to make substitution. So I have 1/3 pi. Instead of r, I'm going to write the fraction 1/2 h. I'm going to square it. And I'm going to multiply by the h that was already there.
So, wait, can you say that again?
Sure. So the
Okay.
volume formula that he gave you, right here,
Uh-huh.
I'm going to take and replace r with 1/2 h.
Okay, got it.
And then I'm going to clean up the result. So v is equal to 1/3 pi. Half of h squared gives me 1/4 h squared times h. Are you with me?
Yes.
Now I'm going to clean up my fractions. I'm multiplying, not adding, so I don't need common denominators here. This is 1/12 pi h cubed.
Okay.
Now what I've done is I've succeeded in writing the volume of the cone in terms of the height. Right?
Mm-hmm.
And so when I go to differentiate this now, I don't need to know what the radius of the water is. I know what the radius of the cone is, but I don't need to worry about the radius of the water changing. Because I did it in terms of the height, yes?
Right.
So now let's do what we're used to. Let's differentiate v with respect to time. So we have dv dt. Remember, 1/2 pi is a constant, so I'm just going to write 1/12 pi, and then I'm going to differentiate the h, so I have 3h squared
Mm-hmm.
dh dt.
Okay, that makes sense.
Okay, now I'm going to clean up my fractions again. So dv dt is equal to 3/12 because the 3 and the 12 cancel. So I get 1/4, 1/4 pi h squared dh dt. Right?
Mm-hmm.
Remember, this is h squared, not h cubed, because the power went down. Okay?
Right.
So now I want to find the rate at which the height is changing. So I want to find dh dt.
Yes.
Okay, not dv dt. So I want to solve. Now, you can plug in at this point, or you can solve for dh dt first. I usually solve for dh dt first.
Okay.
So I'm going to multiply both sides by 4 to get rid of my fraction. So I have 4 dv dt is equal to pi h squared dh dt. Right?
Yes.
Now dh dt is equal to 4 dv dt over
IH.
pi h squared. Everything good so far?
Yes.
Now, once we're there, then we have to plug in what we know,
Or
right?
DVDT.
The DDT they gave us, what is it?
It's 2 meters cubed per minute.
Right, and do we know H?
The height of the cone.
Okay, now remember, this is what I was saying. Don't confuse the H's, okay?
Okay.
So the H of the cone is 6, right?
Yeah.
But the H in our problem is not.
That's right. It's the 4.
Yeah, because we're looking at not the height of the cone, but the height of the water.
Got it. Okay, that makes sense because we derived it, or
Differentiated.
Yes,
We differentiated.
differentiated. Yes.
Okay, does that make sense? But
Okay.
why did we need the height? Why did we need the height of the cone? Because we did need it. Why?
It was in order to find the ratio between the
Exactly. Because
sides.
otherwise we would have needed what?
The diameter. Or-
Well, otherwise we would have needed to know what the radius was of the water here.
Oh, yeah.
So you either have to give me how high is the water going,
Mhm.
like in other words, where am I on this cone, or what is the radius at that time. You have to give me one or the other,
Yeah.
right? Because the radius of my water down here at the bottom near the tip is not going to be the same radius as it is 4 meters deep, is it?
No.
Right? Does that
Mhm.
make sense?
Yeah.
So now we have all the information that we need. So the HDT is going to be 4 times 2 meters cubed per minute over pi, and H we're using 4,
Or
so 4 meters squared. Don't forget to square it, right?
okay.
So we're going to do a little bit of arithmetic. So 4 times 2 is 8, so we have 8 cubic meters per minute,
Mhm.
and we're dividing it by 16 pi, right? And that's going to give us
Is it 16 meters squared? Or how would you do it?
meters, yeah, 16 pi meters
Meters
squared.
squared. Oh, yeah. Okay.
Either way, we're going to come out with
Meters.
half a meter, right?
Mhm.
1/2 pi,
1/2
or
pi.
1 over 2 pi, I should say,
Mhm.
because it's 8 over 16 pi. 1 over 2 pi
Yeah.
meters cubed per minute, meters
Per minute.
per minute, right?
Yeah.
1 over 2 pi meters cubed per minute. And does he want, and he, no, he doesn't say decimal, so we have number 7, yeah.
Oh, okay. Oh, it wasn't too bad.
No, he made it a lot easier than the Sen gauge problem. The Sen gauge problem was harder than that.
Yeah.
I don't think she's gonna give you like one that's as hard as some of the Sen gauge problems were. A couple of the Sen gauge ones were really hard. But does that make sense to you?
Yes. Is it okay if we do one more, or do you have time?
Yeah, I can do it.
I know you'll be there in the morning too.
Yeah, I'll do
Okay.
it. Which
Okay.
one do you want to do? 10?
Yeah, I was thinking maybe number 1, or sorry, 9 or 9.
You want to do 9? Okay, now let me just help you a little bit with this, because you can probably do A, right? But B is where you had problems last time,
Yeah.
okay? So notice this, okay? Now, if you're not sure what X should be, because that's what your problem was in the quiz,
Mhm.
okay? What I want you to do is to do B. We're going to do A, but just so you understand this.
Okay.
If I didn't have this 1 minus in here, and this was just the square root of X, okay? If this was just f of X is the square root of X, I could get my linear approximation and stick that number right in it. And I would be able to do it, which is what you did the first time. If it's 1 minus X, and you're doing 0.9, ask yourself this. How far is 0.9 from 1?
0.1.
0.1. Is it higher or lower? the game show, right? Is 0.9 higher or lower than 1?
Lower.
It's lower, so x will be negative. Okay? Now, the way you figure that out mathematically is you set 1 minus x equal to 0.9. And that's how you figure that out. But that's where you made your mistake last night when you were doing the quiz.
Mm-hmm.
So let's do this one so you can see how it works. Okay?
All right.
So it says f of x. It's not that bad, I promise. F of x is the square root of 1 minus x. Okay? So we're going to do what we've done 100 times already. F of x, we're going to write this as 1 minus x to the half. Okay?
Yeah.
And then we're going to differentiate it. F prime of x is equal to 1 half 1 minus x to the negative half times negative 1. Right?
Yeah.
I'll slow down a little bit. Is that okay?
No, you're good.
So f prime of x is equal to negative 1 over. Now, it might be easier to write it as a radical, so I'm going to do that here. Negative 1 over 2 radical 1 minus x. Okay? That's my f prime.
Okay.
Okay? Now, the first part of this says write your approximation at 0. Okay? So my linear approximation formula is L of x is equal to f of a, okay, plus f prime at a times the quantity x minus a.
Yeah.
Okay? Now, what does that mean we need? We need f of a, right?
Yeah.
What is a?
0.
So if a is 0, right, then the first thing I need to do to get my linear approximation is to find f of 0, right? So f of a is f of 0. Now, where am I plugging it? Where am I plugging 0?
In the first,
I'm plugging it
point.
into f, okay? Plugging it into f. So that means I'm getting 1 minus 0, which is 1. And the square root of 1 is 1, right? Are you there?
Yeah.
So now my point, which is on f, is the 0.01. Okay?
Yeah.
All right. Now, what else do I need according to the formula?
The f prime of a.
F prime of a, and a is 0, right? So where am I going to stick 0 this time?
It's going to be in the f prime of x.
In the f prime, right? I'm going to stick it into the fraction form. You can stick it into whichever is easier for you. But when I stick it in there, what do I get?
You get negative 1/2.
Negative 1/2.
So your point is 0, negative 1/2?
No.
Oh.
This is not, well, okay, technically, yes, that's true.
You don't need it.
But, okay, let me tell you that it's not a, it's a point, okay, but the point is 0, 1, not 0 and a half, 0 and negative half, okay? That's a point on the derivative, yes.
Okay.
But the point on the function is 0, 1. What does the derivative give us?
It gives you the tangent slope.
Right. The tangent slope to f.
Yeah.
So it is a point. 0, negative 1/2 is a point on f prime.
Yeah.
Okay. But I'm not so concerned about the point on f prime. I want the slope.
Okay.
Right? Because I know what point I want, and I want a point on f, not a point on the tangent function. Yes?
Okay.
Yeah? But you're right, it was a point, that's correct, but it's not a point on f.
So the slope is -1/2.
The slope of the tangent line, which is what we're trying to get, is a -1/2, yes. So
Okay.
now we're going to go back to, okay?
That makes sense.
Okay, so now we're going to go back to the linearization.
Okay.
And the linearization is, guess what?
Plugging in.
It's, yeah, but the linearization, if he had said to you, find the equation of the tangent line to the point, at the point 0, 1 to this curve, you would be doing the same thing. Except that you wouldn't need to find the derivative. You would need to find the derivative, but you wouldn't need to use the derivative to find the coordinates because they're already given to you.
Right.
Okay?
Okay.
So, meanwhile, L of x
Mm-hmm.
is equal to f of a. What was f of a? What was f of 0?
It was 1.
1. So we're going to write 1 plus f prime of a is a -1/2, so -1/2 times x minus, what is my a? 0.
0.
So I have f of x is 1 plus -1/2 x minus 0. And if I clean that up just a little bit, I get 1 minus 1/2 x.
Yeah.
That's my linear approximation at 0. That's part A.
And then part B, like what you were saying, you make 1.
So now to find x, because if you're looking at the approximation for 0.9, right?
Mm-hmm.
If you look at that, that's assuming that you did the square root of x, but you didn't, right? So you said, well, 1 minus x, the stuff under the square root, has to equal 0.9. So what does x equal? If 1 minus x is 0.9, then I'm going to move the x over.
Mm-hmm.
1 minus 0.9 is equal to x.
X equals
So
0.1.
x equals 0.1. Because I'm subtracting 0.1 to get 0.9, right?
And that's it?
Well, that's my x, right?
Oh, okay.
But that's not my approximation, is it? Because where does my approximation come from?
Oh, your approximation is based off the linearization function.
Right. The approximation comes from L. Why did I need to do the manipulation to x?
So you have to plug in X.
Perfectly done, yes.
Okay.
So what is my x? Is it 0.9? Is it 0.1? Is it something else?
Your X is
What
0.1.
My x is 0.1. So L of 0.1 is what? 1 minus
1/2
1/2
times
of
0.1.
0.1. And if we plug that in the calculator, because at this time of night, who knows, right?
It's 0.95.
Okay, now here's what I want you to do. I want you to take your calculator and tell me what the square root of 0.9 is. Put in the square root of 0.9 and tell me what you get.
3.
No, not 9. The
Oh.
square root of 0.9.
Oh, okay. I was like, why is she asking me this? Sorry. Okay.
No, you'll see why. You'll see why.
Okay.
Square root of 0.9 is what?
Is 0.94868.
Now that's the real square root of 0.9.
Oh,
The real square root of 0.9 is 0.948.
okay.
What did you just get?
0.95, which
Is
is
your
really close.
approximation close? So you're probably correct.
Got it. Okay. That makes sense.
You see?
Yeah.
Now there's a second part. It wants you to find the linearization of 0.99.
Mm-hmm. So that would be 1 minus X equals 0.99,
Uh-huh, right.
which would be end up being x equals 0.01.
Correct. And then you're gonna, exactly.
Plug
Now
that.
you're cooking with gas. So L of 0.01 is equal to 1 minus 1/2 times 0.01. And what is that?
0.995.
Okay. Now, just to check this, I want you to take the square root of 0.99 and tell me what you get.
That's 0.9949.
And so see how close we are?
Mm-hmm.
And that's how you do that. Does that help?
Yes. Thank you.
Not too bad, right?
Yeah, it's not too bad.
I think I would go to the linearization problem first, because that's probably your problem. You know what I mean? It's like probably the shortest problem on the test.
Yeah.
Actually, it probably is. Although some of the derivatives might be short. I don't know, but
Yeah, I don't know.
probably-
Depending on the ones he asked, I really don't know.
but the linearization problem won't be hard. I mean, you can only, it's just the slope of a tangent line. So there's not much you could do to make it hard. You know what I mean?
Yeah.
It's all it is the slope of a tangent line. So it's not that difficult to do.
Yeah. Okay.
Mhm. So you did the ugly limits. You did the function, right?
Yeah. I know he did number 14 in class.
For you? Yeah, that's the IZT, right?
That's
The IZT and Rolle's theorem. The intermediate value theorem
Mm-hmm.
and
Yeah.
Rolle's theorem together. Yeah.
Yeah, so I'll probably just look that one over because
Yeah.
I haven't really practiced those. And then,
Yeah, sure. No worries.
okay. Well, thank you so much. Have a good night.
I didn't have a chance to record this one, but I have all of the notes from like the last 3 days, and I have like 4 videos too. So if you need to watch anything, if you need me to give you pictures of anything for the test tomorrow, I have all the notes. I just haven't like organized them,
Okay.
but I have them all
Okay.
for like the last, and you should have most of them.
Yeah, I have a stack of papers right
Between
here.
your
So.
phone- between your phone and the, but I mean, if you want me to scan anything and like send it to you so you can like print it in a, I don't know what you do, but if you wanted to print it in a packet or whatever,
Okay.
so
Yeah.
you have the homework assignments for, I think, 2-5, 2-6,
Yeah, I have
2-7,
all those.
2-8, and I'm not sure if I sent you 2-9, but we did it. So I can send you the work if you need it.
Okay, yeah, that'd be cool.
But
And-
just, I'm going to try whenever I can tomorrow morning, I'm going to open up the meeting.
Okay.
So if I can get to it a little before it, I will.
Okay.
But I'll just leave it open so that you can drop in and out. How about your friend? I didn't hear from anybody.
Yeah, I haven't either. I don't know. They're probably doing what I'm doing.
Staying up and trying to
Yeah.
smart think it. Well, I hope you got a lot out of it.
Yes.
I think you did do a lot of problems, and who knows, maybe I think you'll do better on this test.
Yeah.
As long as you can keep from stressing out, you know?
Yeah, I think I learned from that last one.
But
I tend to
also,
do that on my first test. That's
Uh-huh.
always my first one that I always
Yeah, slow starter. Yeah, no, sometimes that happens. I know that I have a phone call expected from Professor McDill, but I'll text her and tell her, don't call me between like 12 and 4 because that could be distracting, but call me before 12 or after 4 o'clock. She
Okay.
lives in the morning, so that's not a big deal.
Mhm.
But I'll leave the meeting open, and even if it means that, like, I just leave it open and you know that I'm there, if that's enough to give you some comfort, then that's fine with me. I can, like, babysit my computer with my mic off and my camera off, so you can look at the black screen if you want to. I don't care.
Well, I'm sure I'll be popping in. And
Yeah.
if anything, maybe if you don't mind sending me that link, and then I could have
Which,
the other people just join me on that one.
which link? Oh, you
Oh,
mean the
for
link for
tomorrow.
tomorrow?
Mm-hmm.
I haven't made it yet, but when I make it, I'll send it to you.
Okay.
Um, yeah, I'll make it in the morning early.
Okay.
I get out of the shower usually around before 7. So I'll make the meeting. I'll send you the link before breakfast, and then I'll start it right after I eat.
Okay. I mean, for the during the test, would you be okay with us
Yeah,
using?
I'll leave the meeting open.
Okay.
That's what I'm saying. I'm gonna leave the meeting open. Like, I don't know if you remember last semester, I had like a 6-hour meeting block. Remember, from 8 to
Yeah.
6.
Uh-huh.
So I'll just leave it open like a big block. But just know that occasionally I might drop out like I did tonight. So just
Okay.
wait for me to circle back, like I'm coming back. But sometimes it can take up to 2 minutes. Or
Uh-huh.
usually in the morning it takes longer to like cycle back and come back. In the evening sometimes it's just really spotty, like
Mhm.
it'll drop out and then it'll come back. But sometimes in the morning it can take like anywhere between 30 seconds and 2 minutes, because if it goes completely out, then I have to reboot my whole computer and log back into Zoom to
Oh,
get
yeah.
back. But just don't leave the meeting, because
Yeah,
if you
'cause
leave the meeting and there's no host, it will close the meeting.
oh,
You know
okay.
what I mean? So
Yeah.
just stay in the meeting, and then I'll join the meeting again, and then you'll be able to come back.
Okay.
Okay?
Yeah, I even asked, I think I told you I asked him if we could take it as a
Yes.
group. He agreed. He said it's fine.
As long as you turn in your own work.
Yeah, it was like sometimes people turn in the same work, but it's wrong.
Yeah, we all agreed, and we all agreed on the wrong thing.
Yeah.
That's unfortunate.
You know me, I usually catch those little.
Yeah, you do. Like, oh, that should be negative. Oh, wait. There should be a 2 there. Yeah, no, that's good, though. That's really good.
It's good, but
All right, I'm going to let you go now, and
okay.
we'll talk in the morning, okay?
Okay, thank you. Have a
You're
good.
welcome. And I did record this, so you might fast forward past the Carla part.
Oh, okay.
But I'm gonna have to upload it in the morning because it takes like a while to
Yeah,
upload.
it's fine. You don't have to worry about it.
But that way, if you want to look at it for like the final or something,
Fine.
like when
Yeah.
you're doing the review, then. Alrighty, well, I'll talk to you later then.
Okay. Thanks.
Bye for now.
Oh, I forgot.
Hmm.
For section 2.8, I think there were like 2 pages that were kind of blurry.
Oh, yeah, uh-huh.
I mean, if you can do it in the morning, you don't have to do it right now.
What pages were they? I have the book, I think. I just need to find it. Oh, Lord. Too many pages. Which pages were they, Sam? 4? I think you said number 4, right?
Yeah,
Number 4 and number.
I know it was.
I think I have the text message, so I'll look at it. Number 4, and I think you said number 13, right?
I got number 4, so it's just number 7 is the one. I don't know if you sent that. You might have sent that one to me. And then number
Mhm. Okay.
12 and number 13.
7, 12, and okay. I'll do it right now.
Okay. Thank you.
No, I have a minute. I can do it right now. It's not that bad. And I have the book right here. So
Okay.
it's not like, because today I brought the book and the scratch papers and the pile. I was like, she's going to need it all. So
Yeah.
let me just. No, I mean, you never know what, you know what I mean? You don't know what the student's going to need. So
Yeah.
let me cam scanner it because it comes out better if I do that. 100, most of the time it comes out better. So let me figure that out. Yeah, I'm working on my tech skills here. We're all getting along as much as we can. Sometimes I forgot to have classes today. That's okay, I can save it for tomorrow. Okay, so let me put that there so that it's flat. Oh, this is an inverted comma to number 7. Yeah, this is that ugly one from, this is
The
the ugly one from
number 7.
Engage. That was
Yeah.
fine. Yeah, I remember that.
Yeah, it was just the picture when you took it. I think you took it kind of at an angle, so I couldn't read like the right side because
No,
it's a
yeah,
notebook.
I like I said, I was in a hurry and I was like
Yeah.
madly flipping pages and I don't do well. 7 and you said 12, right?
7 and 13.
Not 12?
No, I think 12 came out clear. So I have that one. I just need a.
Oh yeah, 13 was the 3-part dilemma. So I'll go over that with Professor McDowell before I talk to you and make sure I know what I'm doing with that. Because I have to explain it.
Yeah,
in the
I actually asked this one to the teacher, and he kind of explained it to me too, a little bit.
Yeah, I
Yes.
mean, the hardest part I think is the setup, but that doesn't mean that it's not hard to do because you can get lost trying to do it.
Yeah, I mean, he did the same thing. I think you did the law of cosines as well.
Yeah, I don't know another way to do it
Yeah.
because you don't have enough information. Maybe there is, but you don't have enough information to do it any other way. I don't think.
Yeah, maybe if I find the paper that he
No, it's okay. I mean,
okay.
you can if you want, but I didn't say I wouldn't do it. Let me share this with you.
Okay.
And then I want you to go into your email and tell me, I have to wait a minute for it to share because it's still doing something. But I want to make sure you can read it. I mean, I want to make sure the picture came out so you can read that.
How do you keep your neck and back from not hurting from sitting so long?
I don't.
Okay.
Yeah. I fake it well, but
I guess, yeah. I feel for people who are in wheelchairs. I'm like, man.
sometimes it's easier than others, and I do have a tilt on this chair that helps with some of that because I redistribute some of the weight. But it does. Summer actually for me is like when it's warmer, it's better because it doesn't
Yeah.
my joints as much. I have a hard time when it's cold or
Yeah.
like when I'm probably tomorrow I'll feel it more because I usually feel it more if I'm tired and I've been working, then I feel it more like the next day, you know. But
Yeah.
it's something that I've lived with for
It's
almost, my whole life. So I mean,
right.
pretty much. I mean, I don't remember. That has gotten something that has gotten more bothersome as I've gotten older, which for most people is the case. But
Yeah.
it's still sending it. But it's just something that is my deal, you know. I don't know if I send it to myself or to you, but let me see if I send
Yeah, I know. I'm not sure what your
it to me. So
belief
huh? let
or
me send it. Let me forward it to you. So um, yeah, because I tend to forward it to myself as well. That way, if it gets lost, then I can just it goes faster if I send it. There you go. You might have it twice now.
okay.
But I want you to go in and make sure you can read it. So if I need to take the picture again, I can.
Yeah, I think. Oh, okay, I got it.
Got it?
Mm-hmm.
Can you read it?
Yeah. Let me see.
That's the first thing.
Yeah.
But how can she read it? Because it needs to be
Yeah,
readable.
it looks a lot cleaner. Okay, yeah.
Yeah. Well, I actually cam scanned it instead of taking pictures of it. So I can cam scanner the whole thing if you need it. But I think some of it was already done when I cam
Yeah,
scanned
I
it.
already did all those. Oh,
Okay?
okay. Thank you so
All
much.
right. You're welcome, Sam. Don't stay up too late.
Okay.
Think
I
of
know.
me tonight, okay? I'm gonna take class and I'll see you in the morning.
Okay. All
Take
right.
care.
You too. Bye.
Bye.